Hello. Okay. So, I was screening the questions of civil services. IAS and IFS, I was screening. Maybe yesterday I was doing the exercise because today I have to take the class. Okay, now? So, in civil services, material science comes around 40 marks. Okay, na? And one question will be in the compulsory bit. That is the way it is. It is, na? I will be reading those questions to you. Before I begin, Mandal Saab cleared everything, na? Production, entire production is screened or jigs and fixture over? Jigs and fixture? Jigs and fixture. Some questions? Because I found jigs and fixture questions. Because he told me that production he has finished. And automation, the app programming he has done. I will give you an example. See, I will just screen the question before I begin. The way I did basically, I purchased one civil services questions, but you know, questions were available only up to 2013. Then I went to UPSC website and downloaded the IAS and IFS question papers. Okay, na? So what I found basically by going through in detail, sometime IFS and IAS questions will repeat. You know that, na? I have seen two questions. I will tell you exactly the questions also that is repeated. So this is some of the questions that I will tell you. See, beginning with 2017. Okay, na? I'm just going through because material science is a purely theoretical subject. What I'm going to do, I will discuss with you the questions first and then I will teach you funda so that you can write an exam. Okay, na? But ultimately we have to write, is it or not? So I will teach you certain fundamentals and then dictate some important points so that you can duplicate an exam. Okay, na? 2017 question number 4B. Just question number you note it down, later on you refer in exam. Okay, I also did the same exercise yesterday. Elaborate the stress strain curve for mild steel. Okay, na? Elaborate on, I think this nobody has covered because it will come from dislocation theory. Elaborate on stress strain curve for mild steel 4B. Now question number 3C, just don't write the question, just write the number. Okay, na? All of you have question papers, na? The kunji that comes. 100 rupees kunji. Okay. Question number 3C, it's a 15 marks question. Elaborate on time temperature transformation curve. This question repeated 4 times in last 6 years, both IFS and IAS. 4 times. And I will go through in detail. Okay, na? 3C, 15 marks. Okay. Now IAS 2016, 1D. Question is, elaborate on the compositions of low carbon steel and its applications. 10 marks. 2C, elaborate on TTD diagram. This is 20 marks question. But of course, question was also something related to draw some cooling curves on the TTD. It is 20 marks question. 2C. 4B, what are the different plastics, blah, blah, blah. Okay, na? That also I will tell you. 10 marks. Total 40 marks. IAS 2015, question number 1E. First question is compulsory, na? So consistently in first question, one question will be for material science, okay, na? And it is easy. I have 4 days lecture, it's very easy. I will tell you the fundamentals and then a little bit, because it's my regular class, I take around 35 hours. But here, you know, we will see some important points. that are repeatedly coming in the exam and dictate one or two important paragraphs, because when we are writing na, things are going to our mind. Okay. 2015 1E, advantage of tempering steel. Show with iron carbon phase diagram. 3C, what is maraging and austenitic stainless steel? You know these materials, maraging steel and austenitic stainless steel. What is ASS? You don't have any idea. Okay, no problem. Maraging steel. But you know, what is the major component? You know, it's substitute for titanium grade 5. I will tell this thing. Yeah? And we make, you know, missile shells by maraging steel. These questions are there in this? No? No? Whatever I'm reading? They are not here. No problem. I compiled from my previous papers. Okay, na? Then I'm 2015 again. 4C. What is annealing steel? Show it on TTT diagram. Okay, na? All right. 2014. Every year around 40 marks. Elaborate on different crystal systems. 2B. What is austempering? Show it on TTT diagram. Practically TTT diagram, one question is there in every year. Okay, na? This is around 10 marks. 3B. What are polymeric materials? Define two polymeric materials. 4B. What are composites? Elaborate on its classification. 7A. What are high energy rate of forming? What are advantages and disadvantages? High energy rate of forming, Mandal sahab covered? Covered, na? High energy rate of forming? I will just keep on writing this thing. I have to cover high energy rate of forming and jigs. Okay. Now see, some of the one problem was there. Actually, kahan gayi wo? हाँ. See, this question appeared 2 times. One is an IFS, one is an IAS. How properties changes when iron converts in from BCC to FCC? 2010 it appeared in IFS. No, IAS. And IFS recently, I think 1 or 2 years back. This is the 2010 IAS. And then, what is bite and nip angle? This is IAS 2012 8A. What is bite and nip angle in rolling? You know that, na? Covered. Okay, good. What is friction hill? Covered. Okay, good. Draw sigma comparator. No? No? Okay. Comparator. It is IS 2012. What are different tool materials? Covered. Okay, good. Manufacturing and forming process. High energy rate of forming is not covered. Okay, good. High energy rate jigs are not covered. Comparators are not covered. And only tolerance allowances are covered. Okay, no problem. The rest of the thing I will take care of. Which programming? The program is not covered. See, देखो एक क्वेश्चन ये है इसका. I think you can easily handle. It's IAS 2012. Question number 8C. Question is an easy one, but anyway, this is a 2-minute job. उसका कोर्स चेंज हुआ है? आपने कोर्स देखा है? एप्ट पार्ट में नहीं है, एप्ट वगैरह. Okay, leave it then. So that's what it is for ISC and IFS. What are dual phase steels? DP steel. Okay. It's a 2015. Okay, DP steel. And what is meant by dislocation? What are grey cast iron and white cast iron? 4B, then annealing, elaborate on annealing. See, this IFS 2014 and IS 2012, it's the same question. What property changes when iron converts from BCC to FCC? Okay, na? It's exactly the same question. Then IFS 2017, question was related to the two planes were given. Draw them. I think 110 and 111. Okay, na? And 2C, draw iron carbon phase diagram. IFS 2017, okay? Then 3D, draw the heating cycle on a TTT diagram. So in IFS also it was, I think, more than 40 marks in material science, okay? IFS 2016, I'm going through the questions first, okay? Na? Then we will see and as a whole. 2016, what are heat and non-heat treatable alloys? Next, why copper is so ductile? No. Non-heat treatable, there are two categories. I will tell you. Why copper is so ductile? It's a 10 marks question. Any answer for that? You know that? No problem. I will discuss. Okay, na? And 3B, once again, there is another question. Yeah, exactly. It's a link to the dislocations only. Dislocation theory. You have learned so many things. You are appearing in mains. Very good. You know many things. 97% aluminum and 3% copper. 3B. So what are the specific properties and how exactly this material behave? You know what is this aluminum copper alloy? It is called duralumin, and it is substitute for titanium. Okay, na? IFS 16 4B. Again TTT diagram. Anyway, Jigs fixture you want to learn. Then high energy rate of forming question recently were there. Comparators. So these three things I will cover it up first. Then come to the material science. Okay. Anything else you would like to add? Anything else? Because I will be discussing on these lines. Okay, na? Welding is not covered. Welding, what is covered? What a non-conventional process means? What you want to learn? I will quickly finish it off. In welding, numericals are done basically on the transformer. Okay, so basically you want to learn power source. Power source, na? Now that's I will discuss that. No problem. It's very easy, yeah, very easy. Anything else you would like me to cover? Welding, especially I have seen, na? Generally, GTAW, GMAW questions a lot, they are coming in IFS and IAS. Huh? GTAW, GMAW. ECM machine is done. And EDM? You have not done. ECM, numerically you would like to know. ECM, EDM? EDM numericals. Because civil services, there was a problem sometime back, I think 4 or 5 years back. Prove that for EDM, for maximum power transfer, short circuit voltage is 72% of the open circuit voltage. 25 marks. It's straight. It's very easy. Huh? 0.72, 72%. You know that? Yeah, anything else you would like to cover? Enemy casting is not there. Welding, this one. Okay, leave it. That's it now. Okay. So what I will do, these are small topics. We will focus on these first. Then I will come to material science. Questions are these. Now, what I am going to do, I will teach a topic, dictate certain important things, and then so that you also got practice. But I will be speaking on along the lines of these questions. Okay, now? And any doubt you have, you are welcome. But let us do this also. You know, 2012, this is IAS 2012 question, but anyway, it's very easy. There is something called APT. In APT, the way we do it, we are writing in the broken English, like chatting language. Alright? So, let us say this line is L1, L2, L3 and L4. How exactly we define these lines in APT? Tento means tangent to. Tangent to. Okay? So how to define line L1? This is the origin. Origin. And from origin you are going towards the center of the circle. From the origin you are going towards the center of the circle. You are walking over that. This is your left side. This is your right side. So you know L1, how will I define L1? It's a line. Line. It's a left tento C1. Left tento C1. And for this circle, let us say C1. This circle is C2. This is the origin. So when you are moving from origin toward the center of the circle, this is also left tento C2. Okay, na? Left tento C1, left tento C2. That is the way I will define this line. Now, how to define line L2? How to define line L2? See? Left and right, how do I do? Left and right, how will I do? You are at the origin, moving towards the center of the circle. Whatever activities that are falling on the left are called left, and whatever is falling on your right is called right. Okay? So now L2, right tento C1, right tento C2. So L2 is a line right, because in APT the concept is, in one word you cannot have more than 6 letters. So right, left means LFT, right means RGT. Right tento C1, right tento C2. And how will I define L3? Right tento C1. No? It's little off. It will be left tento C1, right tento C2. And how will we define L4? Right tento C1, left tento C2. Keep on quickly copy. It's an app program. One word cannot have more than 6 letters. Okay, na? 2012. Okay? Please ask questions, okay? Whatever questions that is there in mind, na, you can ask me, okay, immediately. Yeah, see, between two information, either there should be a comma or a space. Left and tento, there is a gap. Right, because tento is one command, right is another command. Either you separate by a comma or separate by a space. Okay, na? C1 space left space tento space C2. Okay, na? Is that clear? Once again, you are going from the origin toward the center. Your left hand side is called left. Your right hand side is called right. Okay? But you may ask one question. Just 2 minutes you look at the board. You may ask this question that circle and from the origin now my 10 toe is like this. My 10 toe now how will I define this line L1? Because it is exactly falling on the line. So neither it's right nor it's left. Then how will I define this intersection point? This intersection point, because this is also 10 toe, na? This is also 10 toe. So for this line L1, I will say X large or Y large, and this will be X small or Y small. So I can suppose if I am not able to decide based on left or right, I take the help of small and large. So how will I define this line L1? Is line, let us say the circle is C3. Line passing through point P1, and it is a X large 10 toe C3 I have defined. If I am not able to decide based on left or right, I take the help of X large, Y large, X small, Y small, and so on. Is that okay? Anybody was medicine student before? किसी कोई मेडिसिन पहले पढ़ा था? आप और कोई नहीं है? कौन से बैच में थे? Weekend batch 14. Weekend batch. Not talent batch. 15. I taught you. 2015. Talent batch T. मैंने पढ़ाया होगा शायद आपको 15 में तो 14 में आए थे दिल्ली क्यों बीच में थोड़ा सा आया नहीं था मेडिसिन में फिर लास्ट 3 साल से तो पढ़ा रहा हूँ टेलर बैच में रेगुलर बैच में नहीं पढ़ाता ओके इज दैट ओके विद एवरीबॉडी yeah that is the thing see in absolute we use the command go to. See, in app programming, there are 3 divisions. First, app programming, there are 3 divisions. First is the geometry statement. So, whatever I am discussing now, attempting this problem, these are called geometry statements. Okay, na? Now, there is something called auxiliary statement. Auxiliary statement. For what are the auxiliary statement? Feed rate 1.0 millimeters per revolution. Spindle on 400 RPM. These are called auxiliary statement. Now there are something called motion commands. Some called motion commands. Motion commands. Whatever you are talking about is a motion command. Go to is absolute mode. Rapid means it's a point to point. And go delta is incremental mode. But these things will come in motion commands, not in geometry statements. Okay, no? So that was the question. I have just solved it. There are a couple of questions. Let us take the high energy rate of forming first. High energy rate of forming. It's a small topic. See, because these are the mains classes and you have to appear in the mains. Any more, those who are latecomers, anybody else appearing in mains this year? 3 and 3, 4. Total how many? You are also appearing. Total how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 people. Good. So, right concept. Because UPSC, all the mechanical paper, it is set by a set team of 3 people. And I tell there's one professor who is setting presently this year also. Okay. So I think he will be there in that team. Last year also he was there. So anyway, generally in the regular classes, I dictate elaborately and I go elaborately. But here I will be to the point. But if you want further explanation, please let me know. Okay. Na? So let us take the high energy rate. Somebody should remember what I have to cover. Okay. Na? High energy rate of forming, jigs, comparator, power source and welding, ECM and EDM, and then material science. Okay. Na? So today I would like to finish all these things and tomorrow material science. Okay. Na? Somebody should remember. First, let us see high energy rate of forming. Everybody look at the board. I will dictate one paragraph. In high energy rate of forming, this question is appeared recently in IFS and IS both. Okay. High energy rate of forming like explosive forming. What is explosive forming? There is something called explosive forming. Then called electrohydraulic forming. Electrohydraulic forming. Then anybody else, anything else you know name? Electrohydraulic means either, yeah, magnetic pulse forming. You are correct. Last year also you appeared in by mechanical only. Eh? You got some rank? 300, you are very good. You must be in job. Which job you are in? IR, you are improving for IAS. Huh? Good, good, good. See, I appeared in this exam in 98, way back in 98. At that time, there used to 2 papers. So, mathematics and mechanical, I correct. I have appeared up to interview. But BJP government came to power. So, seats was only, I think, 256, 98. And the problem was basically, at that time, I was from UP, some rural background. My English was not good. So, I got only 120 marks in the interview and out of 300. But, after that, I joined ES later on. But, I was inclined more to my devotional activities, so I did not appear again. I chosen to be in the teaching profession after that. So, I think 431 marks I got at that time, 600, out of 600. So, anyway, it's an easy, mechanical is very easy subject. Okay, anyway. In explosive forming, what happens? See, there is one container and there is a die. There is a die. Okay? And over the die, there is a sheet metal. Over the die, there is a sheet metal. Sheet. And in the container, there is a fluid. There is a hydraulic fluid. And here, there is a detonator. 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 So, generally it's a TNT. So, detonator when it explodes. Well, first of all, we will hear, then I will give you 2 minutes break, okay na? So that you can copy quickly. These things will be in the book, okay na? So, no problem. So, when it detonates, a high pressure wave will form and that wave will deform the sheet over to the die and there will be forming. The deformation will be very fast, high energy. all of a sudden entire impact energy I am giving to the material. Similarly, electrohydraulic what happens? It's the same thing, but in the fluid, there are electrodes. There is a capacitor bank. I am charging the capacitor bank. And at a certain point of time, entire capacitor bank is discharged. So there will be a spark. This spark will produce high pressure wave in the fluid. And that forces the sheet over the die. Concept is same. You know what is a magnetic pulse forming? We take a coil, and through that coil we supply current. A workpiece will have its own magnetic field, and the coil will have its own magnetic field. They repel each other. A workpiece need not to be magnetic, but it should be conducting. So because of repelling magnetic field, it forces the metal to the die. It's a magnetic pulse forming. Concept is same. Within 0.1 or 0.2 second, entire forming is done. The disadvantage of this high energy rate of forming is, because the rate of deformation is quite high, life of die will be less. Life of die will be less. Generally, high energy rate of formings are expensive, because with explosive, blah, 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 so many things are there. High energy rate of forming is having all the problems. But there is one thing that only high energy rate of forming can give. What is that? There is only one very, very special advantage that only high energy rate of forming offers. Okay, but how? Now I will tell you. Write stuff in exam. Write stuff. See, what is the stuff? Stuff comes here. This story, anyway, everybody will write. But see the stuff. When we are performing the tensile test, इधर देख लो जरा, ठीक है, 2 मिनट देखो, जबरदस्त दीजिए. जब stuff लिखोगे ना, तो it automatically attracts marks. Okay, that I learned in 98 when I myself was giving exam. Okay ना, stuff लिखो, stuff. उससे बहुत, you will get close to 100% marks in theory. Suppose you are performing a tensile test on the material. Let us say the material, work material we are talking about. This is the stress strain diagram of the material. Okay. In the normal forming processes, like wire drawing, sheet metal forming, forging, rolling, everything, the moment we unload the material, because all the metal forming operation works in the work hardening region. Work hardening region. Huh? So when we unload the material from here, some strains will recover, and these are called elastic strains. These are called elastic strains. So elastic strains will recover. For example, it's a forging operation. Boom. The moment you remove the load, size will increase because of this elastic recovery. Wire drawing. The moment you remove load, shrink. It's all elastic recovery. This elastic recovery is called spring back. It's called spring back. Elastic recovery is called spring back. And practically it will be there in all the processes. So, after forming, we don't know what is the final dimension. After forming, we don't know what is the final dimension. Same stress strain curve if you plot at higher strain rates. For example, strain rate, let us say 0.0001 per second. If you increase the rate of deformation of the material, you know how the curve will shift? It will be like this. See, when the strain rates are varying from 0.0001 to, let us say, 0.1 or 10 per second, when this is the variation in the strain rate, See, the stress strain curve will shift like this. See, yield point will increase and UTS point will go down. Naturally, it happens in the material. In material science, there will be a lot of discussion. Now, but when the strain rate goes as high as, let us say, 1000 per second or 1 lakh per second, you know, at these strain rates, what happens? Even the elastic region starts shifting towards y-axis. And you know what will happen at a certain very high strain rate, 10 raised to power 5 per second, material is almost behaving like that of a rigid plastic. So because there is no elastic region, there is no spring back. So in high energy rate of forming, we get the rate of deformation of this order. So no elastic recovery, no spring back. So whatever is the shape of die, dimension of product will be exactly like that. So most important advantage in high energy rate of forming is very high accuracy because there is no spring back. Everybody's okay? Make it. I will dictate some important sentences to you. Make it first of all. कुछ बना लीजिए, कुछ डायग्राम जरूर शो करना है एग्जाम में, ठीक है ना? देखो बहुत एप्लीकेशन है, बाकी लोगों को मैं इनको आंसर कर रहा हूं। देखो ऐसा होता है कि इसकी बहुत एप्लीकेशन है। जैसे कोई स्पेस शटल है या मिसाइल है, उसमें एक होती है एयर बोतल। एयर बोतल इससे ही बनती है एक्चुअली, हाई एनर्जी रेट ऑफ फॉर्मिंग से दो हाफ होते हैं, उसको ज्वाइन कर देते हैं। उसका प्रेशर होता है बहुत 25 बार अराउंड। एयर बोतल, उसका पर्पस क्या होता है कि स्पेस में तो कुछ भी नहीं है, तो इंटरकॉन्टिनेंटल बैलिस्टिक मिसाइल है, उसको सपोज में डायरेक्ट करने के लिए, और स्पेस शटल है, उसमें कहीं हाई प्रेशर एयर तो चाहिए, तो वो कंपोनेंट इससे बनता है। There are many applications. This is just one application I am giving you. It is also called superplastic forming. Okay ना? तो बहुत प्रोडक्ट है जहां पे वेरी हाई एक्यूरेसी चाहिए, वेरी हाई टॉलरेंसेस, we go for high energy rate of forming, but it is quite expensive. No. ECM is a machining. It's a forming. In machining, properties will not change. Forming properties will change because of work hardening. Tomorrow I will tell you. Not tomorrow, maybe day after tomorrow. Tomorrow I will take up the phase diagram. Day after tomorrow I will take up the dislocation theory. For civil services, dislocation theory is must. Understanding it. Okay, na? So we will go through all these things. ये कैलकुलेटर में क्या करने लगे? Shall we write one paragraph? The punch paragraph so that you can give it in an exam? Huh? Write down. In high energy rate of forming, die life is low. And the process is also quite expensive. But since the material is deformed at a very high strain rate, hence there is no elastic recovery. So there will not be any spring back after deformation of the material. There will not be any spring back after the deformation of material. No spring back after the deformation of material. Full stop. Initially by increasing the strain rate, in the bracket 0.00001 to 10 per second. I'm giving you the range so that you have an idea, okay na? And you can write this data in exam. 0.00001 to 10 per second. Yield point of the material keeps on decreasing. Yield point of the material keeps on decreasing. And ultimate tensile strength goes down. Full stop. But when the strain rates are quite high, in the bracket of the order of 10 raised to power 5 per second, bracket close, comma, elastic region gradually disappears. And material is more or less behaving, like rigid plastic. Full stop. Since there is no elastic region, so no spring back, no elastic region, so no spring back. Everybody is okay? This paragraph you are supposed to write there, okay na? In HERF. Any question? That was our first topic. Now, let us discuss about jig. Because there are frequent questions coming from the jig. कोई सवाल कर रहे हो क्या? बताओ मेरे बता दो. आपका दिमाग बहुत जगह चलता है. गुड. कौन सा सवाल बना रहे हो? कर दिया? मैकेनिकल कितने मार्क्स आए थे आपके? 300 तो अच्छा स्कोर है. Out of 500, 300 is a good score. इस बार थोड़ा ज्यादा ले आओ, 10-15 मार्क्स. ओके, जिग. मैं आपको थोड़ा की सेंटेंस जरूर लिखवाऊंगा मैं. जिग एंड फिक्सचर. बिकॉज ना मेरा परसेप्शन क्या है, इफ यू अंडरस्टैंड ऑटोमेटिकली यू विल बी एबल टू राइट. सो अंडरस्टैंडिंग इज वेरी इंपॉर्टेंट. रटने से काम चलते नहीं है ज्यादा. अंडरस्टैंडिंग इज इंपॉर्टेंट. क्योंकि थोड़ा सा ट्विस्ट एंड टर्न इधर उधर हो गया तो अंडरस्टैंडिंग से आएगा. अब एक चीज बताओ मेरे को. देयर इज समथिंग कॉल्ड जिग एंड समथिंग कॉल्ड फिक्सचर. व्हाट इज द डिफरेंस? I will tell you. हाँ, बताइए. देखो सर, आप इसको ठीक से देखो, क्योंकि एग्जाम में फ्रीक्वेंटली आता है, ठीक है ना. सिविल सर्विसेज में आईएफएस भी दे रहे हैं, आप लोग नहीं ले रहे. आईएफएस कोई दे रहा है? आईएफएस आप दे रहे हो? जंगल के राजा बनाएंगे आप तो. इस साल दे रहे हो? मेंस भी दे रहे हो सिविल सर्विसेज. गुड गुड गुड. तो काफी फ्रीक्वेंटली आती चीजें. इसको थोड़ा 1 घंटा लगेगा, ठीक है ना. जिसको खत्म करते हैं पहले. बहुत इंपॉर्टेंट टॉपिक है. एनीबडी हु डजंट अंडरस्टैंड हिंदी? Anyway, I will speak in English. When I'm speaking in Hindi, it means I'm discussing side things. Okay, na? Telugu? Where? Tamil Nadu? Okay, no problem. Telugu lo samacharam. Okay, na? Because I stay in Hyderabad. Okay, but I will speak in English only, pure English. But kabhi when I'm speaking in Hindi means I'm discussing personally with some students. Okay, bago nara. Huh? Okay. To maintain, I will dictate some important paragraphs first of all here. Okay, na? To maintain accuracy in machining, it is important that every time workpiece is mounted in a single plane, so that machining can take place in a single plane. To maintain accuracy, we have to make sure that workpiece is mounted in a single plane of reference. So the job of fixture is to every time mount the workpiece in a single plane. Whatever is there in the fixture, everything is there in the jig. But jig does one additional function of guiding the tool. Jig does an additional function of guiding the tool. What is the meaning of guiding the tool? As if tool doesn't know where to machine. Why required to guide? As if tool doesn't know where to machine. बताइए. यूपी गए आप? यूपी गए हैं? कहां गए? जबलपुर के. हम यूपी का हूं इसलिए पूछ रहा हूं. What is the meaning of guiding the tool? You are also from North India, na? You are from Karnataka, looking like that actually. Okay. You were our student, made his student before? No? Okay, no problem. Parwale do. So, why we have to guide tool? As if tool doesn't know where to machine? I will tell you one thing. Shaper and planer. Both shaper and planer does exactly the same type of work. Flat work pieces. So why the expensive planers are required when the same type of work can be done by a shaper? What is the answer? This thing I want you to understand. There is a reason I am spending some time here. आप बताइए, आप लोग कहाँ के हो? हाँ? आप? अच्छा, ये सूरमा भोपाली हैं आप तो. प्रीलिम्स कॉल नेक्स्ट ईयर देंगे आप. इस साल क्यों नहीं दिया? क्योंकि यूपी बिहार में होता यही है. आईएएस बनना है. यूपी बिहार वालों को पावर चाहिए. साउथ इंडिया में डब्लू चाहिए, मनी. वहां पावर वर्क का कोई लेना देना नहीं है. डब्लू मीन्स मनी इन तेलुगु. See, when the size of workpiece increases, so we have to increase the stroke length. Now, this stroke or the ram of shaper is like a cantilever beam. Tool is here. So, cantilever beam with the point load. There will be deflection. So, machine workpiece will be tapered. So, once the size of work exceeds beyond a certain value, fix the tool, reciprocate the work. Number 2, wait. 1 minute or so, दे जबरदस्त चीज है. Suppose we are performing a drilling operation. So, drill is rotating at a very high speed. Now, the moment drill touches a workpiece, again it's a cantilever with the beam with the point load. Deflection. hole will become oval in the beginning. So we need a tool guiding element. Means drill is going through a carbon bush. So now that it's a simply supported beam, hole will be straight. In such cases, we need a tool guiding element so that tool doesn't deflect. लिखो थोड़ा सा से. So whenever Jigsaw and fixture problem comes, whatever I'm dictating, those terms should definitely come into that your text. Okay, na? Jigs and fixtures are auxiliary devices. Jigs and fixtures are auxiliary devices used in mass production. Used in mass production. Used in mass production. Full stop. To maintain accuracy in machining, it is important that every time machining is taking place, in a single plane of reference only. In a single plane of reference only. Full stop. So the function of fixture, is to mount the workpiece, every time in a single plane. Every time in a single plane. Every time in a single plane. Full stop. Jig does an additional function. Jig does an additional function by guiding the tool. Does an additional function by guiding the tool. Huh? Anything? Achha, some phone was speaking, I think. See, I don't mind if you record also, because I want you to benefit it. Okay, record whatever you want to do. I don't care. Okay, na? Because some teachers are particular. You should not record and all that. I don't care. You record actually if it benefits to you. Okay, na? Look at the board. Now, for jigs and fixture is exactly the same thing. Whatever is there in the fixture will be in the jig also. Only one element will be additional, that is called tool guiding element, with the help of a carbon bush. Okay. So, what are the components of a jig? Components of a jig. First is locating elements. Locating elements. Then clamping elements. Clamping elements. Then tool guiding elements in case of jig. Tool guiding element, that is in case of a jig only. And finally, there is a jig body. Finally, there is a jig body. Okay? These are some of the components of jigs and fixture. Now, first of all, let us see the locating elements. Because this question also appeared many times in civil services. Elaborate on 3-to-1 principle. Elaborate on 3-to-1 principle in jig design. So, there are 3 locating elements. What are they? There are 3 locating elements. What are they? फर्स्ट इज 3 to 1. आपको मालूम नहीं था क्या? नाम क्या है आपका? शिवम. शिवम शर्मा. शिवम एक मूवी है साउथ इंडियन में, है ना, एक्शन मूवी शिवम. सो व्हाट इज 3 to 1 प्रिंसिपल? मेरे ख्याल से सुने पहले. देखो हम करेंगे क्या, आई विल एक्सप्लेन दिस and 2-3 sentences and notes I will dictate. Okay, but सुन लो पहले. Three to one principle is applied when the workpiece that you are planning to machine is having 3 flat surfaces. 3 to 1 principle can be applied when the workpiece that you are planning to machine is having minimum 3 flat surfaces. See, there are 12 degrees of freedom as far as jig is concerned. There are 12 degrees of freedom. Movement along plus x, minus x, plus y, minus y, plus z, minus z. 6. Clockwise, anti-clockwise rotation about x, y and z. So total 12. Before machining, 11 degrees of freedom must be arrested, because from 12th direction tool will come. So 3 to 1 principle I can apply only when there are 3 flat surfaces. So you know what we do? We use here hemispherical pins. It's a hemispherical pin. So 3 pins we are providing in the base. Suppose this room is a jig body. So 3 pins we are providing in the base. Now question is, why I am using only the hemispherical pin? Any idea? Why we are using only hemispherical pin? थोड़ी देर बैठ लेते हैं. हाँ. Any idea? शर्मा जी? देखिए सुनो. इसका 20 नंबर ज्यादा लाने. देखो बहुत इजी है. What is the first objective of jigs and fixture? To load the workpiece in the same plane. Now, when a flat surface comes in contact with the hemispherical part, it will be a single point contact. It will be a single point contact. So 3 pins I am providing in the base. So when the flat workpiece rests on these 3 pins, it will be a 3-point contact. 3 point can define a plane. So this ensures that every time machining is taking place in a single plane. Bagun nara hai? This ensures that every time machining is taking place in a single plane of reference. That is the primary objective of jig and fixture. But these 3 pins arrest 5 degrees of freedom. How? Workpiece cannot go down. Minus that. Clockwise, anti-clockwise rotation about x and y axis are gone. Now, 2 pins are provided on a plane perpendicular to the base in the length direction. So by providing these pins, workpiece cannot go to minus x. Clockwise, anti-clockwise rotation about z axis is also gone. So 5 plus 3, 3 more, 8 degrees of freedom are arrested. A 6th pin is provided, 3, 2, 1. 1 means 6th pin is provided on a plane perpendicular to the previous 2 plane. So back side, okay. This arrests another degree of freedom, movement along minus y direction. So by providing 6 pins, 9 degrees of freedom are arrested. And the remaining 2 degrees of freedom are arrested by clamping elements. And from top, tool will come to machine the material. So this is the 3 to 1 principle. But once again, 3 to 1 principle can be applied only when workpiece is having at least 3 flat surfaces, otherwise we cannot do it. Everybody is okay? Write 1 or 2 sentences. कोई question है किसी को? Any question anybody is having? इलाहाबाद से कहां से इंजीनियर किया हमने? आईटी कानपुर। कौन सी ईयर में पास आउट है? 14। उसके बाद क्या किया? आईआईटी के कितने लोग हैं यहाँ पे? अरे मोस्टली फ्रॉम आईआईटीज हैं। कहां से? कौन सी आईआईटी? पाटना। मद्रास इधर आप यू आर तमिलियन ना? चलो भाई, इट्स अ गुड बैच. It would have been nice basically if you are a regular batch, because there's a very short class. 50 hours of his time teaching just basically 10 or 12 hours. Anyway, but there is no time. We have to appear and crack mains, is it not? तो कुछ selected questions देख रहे हैं अभी हम, ठीक है ना? लिखो 3-2-1 principle, जो some punch lines, only punch lines. Definitely. Triangular surface, because most important is the base. Most important is the base. Okay, na? Other shapes we will discuss. Okay, na? Flat, no need to be normal to each other. Write down. This principle can be applied. This principle can be applied only when workpiece is having at least 3 flat surfaces. Workpiece is having at least 3 flat surfaces. At least 3 flat surfaces. Full stop. 3 hemispherical pins are provided. 3 hemispherical pins are provided in the base. In the base of the jig. And when workpiece rests on these 3 pins, workpiece rests on these 3 pins, it defines a single plane of reference. It defines a single plane of reference. Actually, rest of the things all of you are brilliant people. You know, it's a full 15 marks question in IAS. So you have to write, see, and by providing these 3 pins, 5 degrees of freedom are arrested how? Minus Z, clockwise, anti-clockwise, 2 pins on the side. This is story, na? You can manage, because this sentence should be there in that, okay, na? Other things, you manage the way I discussed. Specimen cannot go, 6th pin specimen cannot go back, 2 clamping elements, blah, entire story. It's a full 15 marks question comes in civil services. Okay. So, there are 3 locating principles. First is 3-to-1. But 3-to-1 can be applied only when there are 3 flat surfaces. And the second one is radial location. Radial location. सुन लेंगे थोड़ा सा. See, the radial location we use only when there is already one hole in the workpiece. Radial location we use only when there is already one hole in the workpiece. Okay, na? So, suppose this is the work and this is the hole. Now what we do, we insert a conical pin inside. We insert a conical pin inside. And this conical pin will arrest 9 degrees of freedom simultaneously. But the question is, why we use conical pin? Why we use conical pin? Why not cylindrical pin? No, this direction it will not be arrested, even by conical pin. You know what happens? In metrology, we learned that we cannot make anything exact. You know why? Because machine environment follows a normal distribution. So it is impossible, because in normal distribution two dimensions cannot match. So there will be tolerances. Because it's a normal distribution, there will be tolerances. Tolerances are nothing but a portion of probability of normal distribution. So same workpiece, in this hole there will be some tolerances, means slightly big, slightly small. If I use cylindrical pen, either it will be clearance, tuck, 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 or tuck, 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 interference. I don't want any of these things. Understand? Na? To accommodate slight variation in the size of hole due to tolerances, I use conical pen. See, whenever we say tolerance, it is always a group. It is not an individual component. Tolerance we define only for a group, not for individual component. So to accommodate tolerance, we provide conical pen. And then remaining 2 degrees of freedom, how will I arrest? Provide these 2 pins at the side. Everybody's okay? But suppose in any workpiece there are already 2 holes. There are already 2 holes in the work. Let us say one hole is here, another hole is here. You know, how will I locate? In one hole I will put conical pen. And in another hole, I will put a diamond pin. Huh? Diamond pin? A diamond pin. What is a diamond pin? There are 2 sides are relieved. So if I twist that diamond pin, the center to center distance will be adjusted. Center to center distance will be adjusted. Because center to center distance will also have tolerances. To accommodate that, I use a diamond pin. So with the help of diamond pin and conical pin, all the 11 degrees of freedom are arrested in one go. And we can machine any part. But radial location I can use only when there is at least one drilled hole already in the workpiece. Any question? Please feel free to ask any question, okay? No? Right. लिखो जरा. Radial location can be used. Radial location can be used when there is at least one drilled hole. When there is at least one drilled hole in the work. At least one drilled hole in the work. Full stop. In this hole, we insert a conical pen. We insert a conical pen. Full stop. Conical pin is selected. Conical pin is selected to accommodate variation in the size of hole. To accommodate the variation in the size of hole, due to tolerances. Due to tolerances. Full stop. If there are two holes, in one hole we keep the conical pin. And in another hole we keep the diamond pin. In another hole we keep the diamond pin. Full stop. Two opposite surfaces of diamond pin are relieved, and these pins are used to accommodate the variation in the center to center distance of holes. Otherwise, you know what will happen? Workpiece will be either hold like this or this. We want flat. Now the third location is a V location. Third is V location. V location. पहले सुनेंगे थोड़ा सा. See, the V location is meant for cylindrical and spherical workpieces. And it is like a vice. There is one fixed V, and your workpiece is here, and there is another movable V. It's a movable V. Just like a vice. But V locators are used only for cylindrical and spherical workpieces. Okay? So we choose the locating element according to the geometry of work. Got it? Quickly. We'll use the locating element according to the geometry of the work. There is one fixed V and there is a movable V. ठीक है? सब ठीक ठाक है? Over? So there are three locating elements. Now there are some clamping elements. Clamping elements. See, the basic principle of clamping element is Loading and unloading should be quick. We cannot consume a lot of time in clamping and unclamping, because the basic purpose of jigs and fixture is that it increases the production rate. But when there are lengthy screws, loading and unloading will take time. So lengthening will be quick, should be quick. So some of the clamping elements that we use in jig are strap clamps. Strap clamps. It will be better if the jig question comes to try to give some diagram. Okay na? Strap clamps. Look at the board. बहुत easy है. पूरा production ही बहुत easy है. देखो ये base है आपका. And the workpiece is kept like this. Workpiece is kept like this. Now see, the strap clamps are like this. Okay? And see, these are strap clamps. So put the workpiece, tighten the bolt. So the clamp will apply pressure on the work, and within no time it will be clamped for quick clamping and unclamping. But strap clamps can be used only when the cutting forces are low. Strap clamp can be used only when the cutting forces are low. Because you know what will happen when the cutting forces are high? The workpiece will come out of the strap clamp. In that case, we can go for pneumatic clamps. We can go for pneumatic clamps. Pneumatic clamps. एक सेंटेंस लिखो. स्वेटर निकाल लिया. You are feeling cold? हैं? एसी बंद करवा दें क्या? हैं? श्योर ना? फ्रंट एसी बंद करा देते हैं, ठीक है ना? किससे बताऊं? वो हमारी आइडिया है. इस एसी को बंद कर दो. सामने वाले को, सामने वाले एसी को बंद करो. मेरे को संदर्दी लग रही है इसलिए बोल रहा हूं आपसे. क्विकली मेक ए स्ट्रैप क्लैम्प. इट्स वेरी इजी. हाँ, अरे बाहर से ऑपरेशन इसका लग रहा है. Strap clamp. You are scoring paper 1 more or paper 2 more? Civil services. Paper 2 is scoring more. That is an easy one. Actually, thermo is easy. Paper 1, how much you got? Oh, okay. What is the weakest area in there? Production theory. Manufacturing is production only, na? So let us see. Whatever doubt you ask me, okay, na? Those who are appearing immediate mains, na? So please ask me whatever doubt you have. Entire production, Number C, because a civil services batch, it's a small batch, I will give my number. But please actually don't circulate to once, because I'm a reserved person. I don't basically give to students, okay, na? But call me, I will tell you what time. You can call me 9618037605. But please don't circulate to other students, because Saket and all that will be too much for me. I don't give to students, okay, na? So, but call me in the evening only, somewhere between 8 to 8:30. It's a good time for me, okay, na? Generally I don't give numbers. Okay, so those who are appearing in the mains, please welcome whatever you want to ask me, okay, na? From entire manufacturing and industrial, including material science, okay, na? Okay, all right. So strap clamps, I will just write down. The basic principle of clamping is, my name is Dr. Swadesh Singh. Okay. The basic principle of strap clamp is loading and unloading should be quick. Loading and unloading should be quick. Loading and unloading should be quick. Full stop. In strap clamps, although loading is quick, loading is quick, but it is meant for only for low and medium duty work. In the bracket, cutting forces should be low. Cutting forces should be low. Otherwise, workpiece will come out from strap clamp. Otherwise, workpiece will come out of strap clamp. Full stop. When the cutting forces are high, we go for pneumatic clamps. Okay. Next is hinge clamp. See, hinge. It's very easy. This is your work. Hinge clamp can be applied only, just look at the board, 2 minutes, it's very easy. Hinge clamp can be applied when there is one hole in the work. And hinge is like this. There's a hinge. जैसे ना एक है उसके अंदर टांग दिया ऐसे. But once again, hinge clamps are meant for only for when the cutting forces are low. Okay na? Hinge लटका दिया ऐसे लगा हुआ है. Hinge clamp. Now next type of clamp is toggles and wedges. Toggles and wedges. Toggles and wedges. Toggles and wedges you must have seen. Like in the villages, na, there are trunks. Villages, there are trunks. So center portion you are putting lock. See on the side, there are toggles and wedges. You put like this and do this. These are toggles and wedges. So toggles and wedges are also used for quick clamping and unclamping. पीछे वाला चल रहा है इसी ना? नहीं, ये कैसे चला देते हैं, otherwise suffocation होगा. पीछे वाला चला दो, इसी आगे वाला बंद कर दो. हाँ, ऐसा करो, दोनों मत करो. ठीक है ना? पीछे वाला चला दो इसी. Okay? Toggles and wedges are used for quick clamping and unclamping. Okay na? 2 minutes, look at the board. See how exactly we design. The jigs. Number 1. I think you write it down, this thing. Steps in designing a jig. Number 1. Plan elevation. Number 1. Plan and elevation are drawn with the red pencil. It's a standard procedure, okay na? Plan and elevation are drawn with the red pencil. Number 2. According to the geometry, According to the geometry, identify the type of location. Identify the type of location. Number 3, identify the places where the clamping has to be done. And number 4, finally, draw the jig body. Draw the jig body. Draw the jig body. 2 minutes on the board. 2 minutes on the board. Suppose this is the work. Let us say this is the elevation and this is the plan. Okay? And I have to design a jig for that. I want to make 2 holes here. One here and another here. I want to make 2 holes in the work. And for that I have to design a jig. So practically whatever question comes to an exam, follow the stereotype, exactly the same procedure. Whatever question comes in exam, you are feeling cold. Those who are feeling cold, come front. Because if you switch on both the ACs, then it will be suffocated. All of you are okay? Alright. So follow exactly the same procedure, whatever type of design comes to you. Because there are 3 flat surfaces, use 3 to 1 principle. Okay, na? So 3 pins are on the base. See, these pins will be on the back side. Like here. First pin. Second pin. Third pin. 2 pins will be on the length side, perpendicular to this plane. So 1 pin here. Another pin here. And these pins will be visible in the elevation like this. Is that correct, na? Because the back side. See, no pin is below the hole. See here. No pin is below the hole, because otherwise how the machining will take place. And the 6th pin is here. 6th pin is here. After locating elements, draw the jig body. After drawing the locating elements, draw the jig body like this. The jig body. And see, wherever you have to do hole, just above that there will be a carbon bush. Wherever you have to do hole, there is a carbon bush. And remaining 2 sides there will be clamping element. Remaining 2 sides there will be clamping element. So first clamping element is here. Clamp. And this clamp can be seen in the plan also. And 1 clamping element will be from the front. 1 clamping element will be in the front. And the rest are normal hatching lines. See, it's a box. It's a box. So you know how it works? It's a box type jig. Front side there's a door. I will look at the board first. I will give it 2 minutes break. Open the door. Throw the work. Close the door. Clamp come from here. Clamp come from here. Because rest in the other three planes there are locating element. 2 drills will come. Do hole. Go back. Open the door. Take out the work. Throw it away. Put another one. Mass production. And the gap between the work and the jig body, this gap is called swarf clearance. Swarf clearance. Purpose of swarf clearance are two: to accommodate chips and to allow freehand movement in the jig body. Jig design. Note down quickly. Any question on that? Any question? See, by this knowledge, you can hit any question on jig now. मास प्रोडक्शन के लिए, जिसका प्रोडक्शन रेट बहुत ज्यादा होना हो, क्योंकि देखो होगा क्या, जब भी वर्कपीस की डिजाइन चेंज होगी, जिग की डिजाइन भी चेंज हो जाएगी. इट इज ऑलवेज फॉर मास प्रोडक्शन, नॉट फॉर unit or batch production. It is not for unit or batch production, always for mass production. Up to this point, everybody is okay? कोई सवाल पूछना है आपको जब तक बाकी को कॉपी कर रहे हैं? कोई सवाल नहीं? पूछो भाई, कुछ भी पूछो. एंटायर प्रोडक्शन से कुछ भी पूछ सकते हो रैंडमली, जबकि फ्री टाइम है तो, ठीक है ना. फ्राइडे तक क्लास है हमारे यहाँ पे, तो तब तक कुछ भी पूछ सकते हो. चाय हम पीते ही नहीं है, पानी पियाएंगे थोड़ा सा, और पानी हम ज्यादा पीते हैं. कुछ है दिमाग में आ रहा है कुछ? वो उसके बारे में रुको, मेटेरियल साइंस और डिटेल डिस्कस, 3 दिन पूरे मेटेरियल साइंस के लिए रखेंगे, कल परसों तरसों, तो सब कुछ पूरा बताएंगे कैसे बनता है पूरा. टीटी डायग्राम क्वेश्चन बहुत हर साल आ रहा है कुछ न कुछ, तो मैं एक दिन पूरा टीटी डायग्राम ही पढ़ाऊंगा आपको डिटेल में. उसके अलावा पूछिए, ये पता नहीं ये क्वेश्चन भी आ गया, पता नहीं एक्सपेक्ट नहीं कर रहा था. सिविल सर्विस का क्वेश्चन है, व्हाट इज डीपी स्टील, ड्वेल फेस स्टील. आई वाज शॉक्ड बिकॉज यू नो इट्स अ रिसर्च रिलेटेड थिंग. डीपी स्टील, you know, this question is civil services, yaar. Yesterday I was compiling all the questions for last 5-6 years. So I was shocked basically, you know, DP steel, that is not level में पूछने लोग, तो एक और लेके आना इसे. तो वेरी गुड क्वेश्चन कम्स इन मटेरियल साइंस. और मैं ऐसा करूंगा, जो 3 दिन आप ना कल परसों नरसों अगर आप अटेंटिव हैं, so I think most of the questions you will be able to hit, because entire material science is difficult because it's a very short period. But anyway, the way questions are appearing, उसका आपका जुगाड़ कुछ करा ही देंगे. चलिए ठीक है ना, आप अटेंटिव रहेंगे तो आपको कोई दिक्कत नहीं आएगी. इट इज वेरी गुड क्वेश्चन. डीपी स्टील, डीपी स्टील पता है कहाँ यूज होती है? जो मल्टी स्टोरी बिल्डिंग्स होती हैं, क्या कह रहे हैं, बताइए. कुछ और बोल रहे थे क्या? मैंने जो आंसर बता रहा है. जैसे आरसीसी स्ट्रक्चर में जो रीइंफोर्स्ड स्टील होती है, पर जनरली हम डीपी स्टील यूज करते हैं. क्यों? उसके बारे में डिस्कशन करेंगे. बहुत अच्छा, बहुत इंटरेस्टिंग डिस्कशन है. ठीक है, एक आ गई, एक बोतल आ गई. ऑलराइट, सो दैट वाज योर जिग. सो व्हाटएवर जिग क्वेश्चन कम्स इन एग्जाम, ट्राई टू फॉलो दिस राउट and try to make only box type jig. Okay na? Huh? No. Jig, first of all, there has to be locating element. It makes sure जो jig fixture होते हैं ना, it is basically workpiece specific. So whether work is basically hold in the same plane again and again or no, that we have to see first. Yeah, tool posts are not jigs. Okay, na? Because over the tool post there is a tool. Between the tool and workpiece there will be a medium. That is called a jig. I mean the tool guarding element of a jig. Okay, na? Anything else? Okay. So now, second topic is over. The third topic is, let us say, unconventional machining, because the numericals. Okay, na? No, you can say chucks are fixtures. That you can definitely can say. Especially 3-jaw chuck is a type of fixture, because every time it is loading in the same plane again. That definitely can say chucks are cylindrical fixtures, not jig. Jig means there has to be tool guiding element. And concept tool guiding element kya hai? The same drill rotating. The moment it touches, it's a cantilever point load, so we need a support. Shaper and planer. Jig will come in that way. Otherwise, it's all fixture. Pani piyenge, kya karenge? Everybody is okay? Let us go for unconventional machining. See, those who are going for next year means, try to understand. And if you understand, your answer will be really very beautiful. Very beautiful answer will come out. So now, let us have discussion on, first of all, ECM. Theory you have already studied. Let us go for derivation. And a lot of question comes in UPSC. In ECM, the way machining is taking place is by electrolysis. 10-15 minutes we will discuss, okay? Derivation हुआ discuss derivation. Derivation में मैं theory पर जा ही नहीं रहा मैं, because it will take a lot of time. Is electrolysis, mass of material removal is proportional to charge. Mass of material removal is proportional to charge. So charge is nothing but IT. Q is equals to IT. So this mass, if I remove this proportionality, it is ZIT. Okay, na? Z is nothing but E by F. Okay, na? F is called Faraday's constant. Faraday's constant. And its value is 96,500. 96,500. And E is atomic weight divided by valency, and it's called chemical equivalent. And it is called electrochemical equivalent. Okay? Generally, whenever we are expressing the material removal rate, our unit is also always volume per unit time. Whenever we are expressing the material removal rate, it is always volume per unit time. But this is the mass. If you want to calculate MRR in ECM, it is mass divided by density and time. That's what it is. So if I put everything, this MRR will be nothing but EI over F rho. EI over F rho. Everybody is okay? Huh? See, this factor is called specific MRR. This is called specific MRR. E over F rho. In unconventional machining, is there any relative motion between the tool and work? Yeah, it is there. Because there is no cutting force, but there is a relative motion. Why? Because the rate at which the workpiece is getting consumed, with the same rate, tool has to be fed towards the work. So there is a movement of tool equivalent to what is the rate of erosion of workpiece. So here, electrode feed rate. Because you have to maintain the constant gap between the tool and the work. So the rate at which the tool has to be fed towards the work is the rate at which we are consuming the material. So electrode feed rate will be nothing but a specific MRR into current density. Current density. Let us say S1. Current density is nothing but current divided by the cross-section area. Which cross-section area we are talking about here? Tool front area. Because through the tool front area only current is going through. This area, which area it is? The tool front area through which the current is flowing. Okay, na? And we know that I is equals to delta V by R. The same I. V is the voltage difference between the tool and the work. And R is the resistance of what? Tell me. Resistance of? No, electrolyte. Because electrolyte between the tool and the work is the conductor. So what is the resistance of electrolyte? This R is nothing but rho S into L by A is the electrical resistivity. Electrical resistivity. And what is this L? Anybody know what is the L? Very good. Tool workpiece gap. L is the tool workpiece gap. So you can calculate with all this data. You can calculate electrode feed rate and MRR. Everybody's okay, na? Remember one thing. All these, two things you have to remember. Number one, all these formulas will hold good only when you are following a CGS system. So whatever unit is given to you, convert everything into CGS, centimeter, grams, and second. Otherwise, answers will be wrong. So centimeter, gram, second, amperes, volt, that should be the unit. CGS, everything should be CGS before you operate. And number two, that is very important. Number two, समझ रहे हो ना? Number one, CGS operate CND. And number two, that most important thing that you have to remember, if the workpiece is an alloy, this E chemical equivalent and density no, should be calculated by rule of mixture. Generally, if the density is given, calculate E by rule of mixture. And when both are independently given, calculate by rule of mixture. For example, 1 by E will be nothing but X divided by E1 plus 1 minus X divided by E2. ये rule of mixture ही तो होता है. Property let us say density is summation of I is equals to 1 to N Xi by rho I. That's a rule of mixture. Reverse करके होता है वो. So, in case of alloy, calculate E and rho by rule of mixture. ये दो चीज ध्यान रखनी. CGS, and the ruler mixture. Everything will be okay. You have any question here? No, we don't have any question. ECM. Previous question है ECM का ना? कहाँ है वो question है होगा? 16, 17 में से क्वेश्चन है? 17 वो कहाँ है? पेपर है आपके पास? पेपर लाया नहीं एक्चुअली मैं, क्यों इतना सा बंडल लगाने का फायदा? 16 दोनों में ECM के क्वेश्चंस हैं. वो कुंजी है क्या? यूपीएससी में डाउनलोड कर लो, अदरवाइज होगा, डेफिनेटली होगा. है आपने तो बहुत जबरदस्त पढ़ा है इसे. बुक को पुरानी कर दिया आपको 2 महीने में. इसमें 2012 तक है मेरे ख्याल से ना, 16 तक है, 17 है. अरे गुड. पता नहीं मेरे को जो मिला था पता नहीं. मैकेनिकल इंजीनियरिंग पेपर 1 कौन सा? हाँ करेक्ट 5A है, करेक्ट 5A है. गुड गुड गुड. Shall I remove or wait about 2 minutes? Remove everything? It's easy, na? Once again, all this operation, remember, sometime intermediate in ES and GATE, na? Sometimes question comes from intermediate stages also. So there I follow basically very slow approach and all that, because mostly people they don't know any basics. Okay, that's the reason I go very slow. कौन सा? No. Current. No. See, one mistake all of you are doing. If you are machining alloy, rule of mixture will be applied only for workpiece. But current and voltage are fixed between the work and tool. Na? So the workpiece material, what depends? Density depends. And chemical equivalent E, because atomic weight by valency, that depends. Rest, it's a fixed. Everybody's okay, na? Huh? 2017. Question number 5A. Question number 5A. Fifth question है, compulsory question है ना? हाँ? Okay, good. जर्नी मैंने देखा यार, IAS के क्वेश्चन इजी होते हैं. ES questions are somewhat little complicated. ES questions are very easy. If you work a little bit, na, you can get very good marks in this one, IAS. Electromechanical machining of 400 millimeter square area is performed using supply voltage of 15 volt. Tool workpiece gap is 0.3 mm. Considering the gap resistance of the flow of current through electrode light, see all this data is given to you, 0.0015 ohm. Calculate the metal removal rate in meter cube per second. It should be millimeter cube per second. Anyway, we'll see. Okay, na? Because maybe quite possible there is some misprinting. Meter cube per second will be hardly no. It's a quite. Okay, it is given valency 2, atomic weight 55.85, density 7860 kilograms per meter cube. Faraday's constant 96,540. See, first convert everything into CGS. Otherwise, units will not match. First convert everything into CGS. चलो यही कर लेते हैं. तो देखो, this will be 0.03 centimeter, 7.86 grams per centimeter cube. अरे everybody is okay ना? Huh? Correct na? CGS I have converted. E is nothing but 55.85 divided by 2. We have to calculate MRR. So for MRR, F is available, rho is available, E is available. Oh, I we have to calculate. I is nothing but delta V divided by R. Delta V is there, R is there. Calculate this MRR. But remember, this MRR, whatever you are getting, will be in centimeter cube per second. Convert into meters cube per minute. Tell me what is the answer. Okay? Everybody is okay, na? Convert into CGS. Answer will be in CGS. And whatever answer you have to present, you have to calculate in that way. This is 2017. 16 में भी था क्या? Let us see. Yeah, 16 also question is there. Very good. आ गया? आपकी कैलकुलेशन काफी फास्ट है. कितना टाइम लगा रहे हो आप तो हैं? हाँ, कुछ हुआ? देखो, ओम में ले रखा है. ओम मीन्स रेजिस्टेंस. If the resistivity is given ohm centimeter, here the unit is resistance is given to you. See, in IAS question, you know, it was a very beautiful question in GATE 2016, where they have given some other term they have given, neither resistance nor resistivity, and the unit was centimeter inverse ohm inverse. For rho s, you have to inverse that factor. Be careful. Resistance unit is ohm, resistivity is ohm centimeter. Be careful. Okay na? हाँ. 3.68 meter cube. See, in the original paper, quite possibly it will be millimeter cube, because nobody asks in meters cube per second. But anyway, you see, in actual question, quite possible there may be misprinting. Okay, na? Quite possible. Generally, whenever they ask MRR, it will always be in millimeters cube per second. Okay, na? Correct answer. 3.68 into 10 raised to power minus 7. इसमें actually IAS questions are very simple if you know the funda. And syllabus is also only 70%. Design is not there, and casting is not there. Industrial also a little bit. So for IAS, mechanical is a good option. ES का only 70% syllabus है ना? ज़्यादा syllabus नहीं है इसका. और देख कितने कितने इजी क्वेश्चन आ रहा है. ECMS ES के क्वेश्चन देखो, कभी बहुत अच्छे क्वेश्चन होते हैं, कभी गेट के क्वेश्चन देखो. लेवल ऑफ सम ऑफ द दीस गेट क्वेश्चंस इन अनकन्वेंशनल मशीनिंग इज क्वाइट हाई. 6A IAS 2016. शर्मा जी निकला क्या? आंसर क्या है? आ गया सही? क्या टाइम की जरूरत ही नहीं है, क्योंकि मटेरियल रिमूवल रेट में पर सेकंड में आ गया ना. अगर आपको ये मालूम करना होता कि कितना टाइम लगेगा मशीन होने में, तो बात दूसरी थी. MRR पूछा बस. कोई जरूरत ही नहीं है, कोई जरूरत ही नहीं है. जरूरी थोड़े सारा डेटा यूज करो आप. ओके, कैलकुलेट द करंट रिक्वायर्ड. हियर इट इज आस्किंग करंट for electrochemical machining of a pure iron to achieve the metal removal rate. भैया कुछ मिसप्रिंटिंग ही यार इसमें. 800 meter raised to power 8 per minute. Oh, I think it should be millimeters cube per minute, I feel, because you know how it is written. 800 meter raised to power 8 per minute. You know what I feel, the actual question, you see UPSC, you can download this one. It should be MMQ. I am 100% sure in actual paper. Okay, na? So anyway, MRR is given to you. Faraday's constant 96,500 E निकाल लो इसे. Atomic weight by valency means 56/2. Density of iron 7.8 grams per centimeter cube. So see, this also has to be in CGS. So it will be 800 multiplied by -3 na, divided by 60. Check whether it is okay or no. Are you okay? CGS I have converted. So MRR is nothing but EI over F rho. Put everything, you will get I. Kitna easy hai? Easy na? बहुत easy. These questions are very easy, damn easy. क्या लोग समझ चुके हैं बोलते भाई है ना, क्या इंजीनियर्स को भी कंपटीशन में रखना है ना, तो आईएएस का कभी पेपर मैकेनिकल का टफ नहीं बनता. आपको मालूम होना चाहिए क्या करना है बस. कितना इजी पेपर है. और देखो 10 मार्क्स, 4 लाइन में 10 मार्क्स कौन दे सकता है बताइए. और मेरे ख्याल से 5 मिनट. बहुत इजी है. इंडस्ट्रियल खत्म हो गया आपका? नहीं हुआ. इंडस्ट्रियल खत्म नहीं हुआ. पेपर लीजिए आप अपना. मैं देखो कुछ और चीज बताऊंगा इसमें. पेपर आपका है ना? किसका पेपर है? ओके. 4 लाइन्स 10 मार्क्स. कितना आंसर आ रहा बताना. हाँ, एम्पियर्स. इसमें देखो 2 चीज ध्यान रखना. नंबर 1, all the units should be CGS before operating, and if it's alloy, apply the rule of mixture, otherwise there will be major problem. Okay, you will do that, na? Some of the IES questions you can do, okay, na? If you are little curious how to operate it. Just a minute. Is our IES workbook? हाँ, ये रहा. See, this is IES problem. Not IES, in fact, GATE problem. Cobalt, निकल, कंपल्सरी. सारे जो फॉर्मूले ऑपरेट होंगे सीजीएस में ऑपरेट होंगे. नो 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 नो, बिकॉज एम्पियर एंड वोल्ट विल नॉट मैच. Because in these formulas, current is also there, voltage is also a resistor. This thing will not match. It has to be in CGS. There may be some problems later on. Convert into CGS. Because ampere and volt sometime may not match. For example, electrode feed rate you want to calculate. There will be error. Each try. Electrode feed rate with the question is asking if you follow this MKS system, there will be problem. देखो इस क्वेश्चन है. There is an alloy. You have any question? हाँ. हाँ. सब सीजीएस में. सब कुछ सीजीएस में कन्वर्ट करो. अदरवाइज प्रॉब्लम होगी. कुछ कुछ क्वेश्चन ऐसे हो सकते हैं क्योंकि यहां पे जो वैरायटी हम डिस्कस ज्यादा कर नहीं सकते. Ohm. In this formula, it will match with CGS. गेट में there was a very beautiful question. अगर आपने CGS सिस्टम फॉलो नहीं किया ना, तो forget about it. You cannot get, never get answer. Yeah, tell me. There is no unit. It's a constant. No. It's a. उसमें actually ना इसमें that will not match. Basically, frankly speaking, if you follow CGS system, there will not be an issue here. For example, V is equals to IR, voltage, ohm, current. Voltage is nothing but ohm into current. देखो ये question IES का है. There is an alloy. and this contain 18% chromium, cobalt, 62% nickel, and 20% chromium. There is an alloy, and you have to do electrochemical machining, and atomic weight of cobalt is 58 सब डेटा दे रखा था आपको. Valency 2 58.71 valency 2 51.99 valency 6. Density of the alloy is 8.28 grams per centimeter cube. Current is 500 ampere. What is MRR? That was the question. Okay? Nikalna jara. So again, see, density of alloy is given to you. You just have to calculate E. So E will be 1 by E is nothing but 0.18 into 2 divided by 58.9 plus 0.62 into 2 divided by 58.7 plus 0.6 multiplied by 0.2 multiplied by 6 divided by 51.99. So rule of mixture. And then calculate MRR. Convert everything into CGS. Otherwise there may be errors later on. हाँ, अगर तीनों की डेंसिटी अलग अलग दे रखी होती, सेम रूल ऑफ मिक्सचर आई विल अप्लाई इन द डेंसिटी. गुड. ये हमारी वर्कबुक में है जो हम ईएस के लिए कराते हैं, उसमें है क्वेश्चन है, इसलिए मैंने दिया क्योंकि टेस्ट देने के लिए आपको. ठीक है. आ गया? All of you are champions, I think. What is the answer? सेंटीमीटर क्यूब पर सेकंड ना? ओके. ठीक है. आप ईएस वगैरह नहीं देंगे क्या? सिर्फ आईएस. ईएस दोगे हैं? अभी प्रीलिम्स दे रहे हो? ये इसका सिलेबस थोड़ा बड़ा सिलेबस है कि मटेरियल साइंस में भी देखो बहुत सारी चीजें ऐड हो जाती हैं उसमें. करोजन हो गया, नैनो हो गया, और बहुत सारी चीजें कुछ वहां ऐड हो गई. प्रोडक्शन में कास्टिंग हो गया, डिजाइन हो गया, फ्लूइड मैकेनिक्स. कैसे करोगे इसे? अपने आप कर लोगे? इंजीनियरिंग कहां से किया आपने? अच्छा, देहरादून पेट्रोल यूनिवर्सिटी. आईसी. ओके. कैसा पढ़ाते हैं? ठीक ठाक पढ़ाते हैं? ओ, गेट देने से कोई फायदा नहीं है आपको. पता है क्यों? न तो आपको कोई जॉब मिल पाएगा इस ब्रांच से. किसने सजेस्ट कर दिया आपको ब्रांच? अच्छा. गुड. अगर कैंपस से जॉब नहीं मिलेगा इस ब्रांच को ना, तो बाहर से निकलना बहुत मुश्किल हो जाए. क्योंकि जो भी गेट में अच्छी रंग का गई ना, IUCL BPCL आया था, तो दे वांट P&I और दे वांट मैकेनिकल. BHL में बस, और कहीं भी नहीं है. मैकेट्रॉनिक्स रोबोटिक्स IUCL में है. बाकी ज्यादा पब्लिक सेक्टर एंटरटेन नहीं करते इन चीजों को. चलो ES IS निकालो, कहां चक्कर में पड़े हो, समझ रहे हो ना? Everybody's okay? Here there is one more concept. Because these IS questions were terribly easy. There is one more concept. Please be careful of that. Please hear that concept. Sometimes, please hear that concept. Because in IS 2 times this question appeared already. There is a concept called overvoltage. There is a concept of overvoltage. And they will ask you calculate the supply voltage. Okay, na? Then what you should do, in all these formulas, whatever delta V you are using, It is the voltage difference between the tool and the work. To calculate the supply voltage, you add over voltage in that. To calculate supply voltage, whatever voltage comes out from here, you add over voltage, you will get the supply voltage. Please remember that. Okay na? Just note down somewhere. ठीक है? Okay? Any question anybody wants to ask? कोई सवाल? 36 सवाल कोई? आपका नाम क्या है? दे रहे हो इसमें नेट प्रीलिम्स दोगे दोबारा से? इस मीन्स दे रहे हो, वेरी गुड. कुछ रैंक है पहले आपकी? थोड़ा भजन करो, क्योंकि आईएएस में भजन की बहुत जरूरत है. समझ रहे हो ना? कितने मार्क्स थे फाइनली आपके आईएएस में, मेंस में? 780. ओ, थोड़ा सा कम रह गया है. भाई लोगों के तो 300 हैं. I think 340, 350 easily you can get it. If you work hard, 350 easily you can get it. और बाकी उसमें करो, देखो स्कोर 350 तो आराम से आ सकता है. हाईएस्ट कितना है आजकल? हाईएस्ट 330 है. किसका है? 337 है. ये गॉस कौन सी रैंक है इसकी? ओह, हाँ. किसी की मैकेनिकल में कोई 100-200 के बीच में रैंक है एक दो मेरे ख्याल से. कौन सी? नाम क्या है इसका? अच्छा, क्या करेगा? आईएएस मिल जाएगा, नहीं मिलेगा उसे? आईपीएस ही मिलेगा शायद ना. आईपीएस में कहां तक मिलता है जनरल को? अच्छा, आपकी कौन सी रैंक थी? 200 समथिंग. आईएएस मिल गया आपको? अच्छा, रेवेन्यू. चलो, आईपीएस में जाओ और हैदराबाद आओ. अभी हैदराबाद में ट्रेनिंग होती है, उसमें होगा क्या पता है कि अभी इस साल जो निकले कैडेट वगैरह ना, उसमें सिर्फ 3 लोग पास हुए हैं, बाकी सब लोग फेस हो गए. हेडलाइंस बन गई है. पता नहीं पढ़ते लिखते क्यों नहीं है. जो भी मिल जाता है ना उसका कोई पढ़ता लिखता नहीं है कि नहीं? पता नहीं क्या करते रहते हैं लोग. है तो एग्जाम तो बहुत इजी एग्जाम होता है वो. उसे क्रैक करने में क्या प्रॉब्लम है? फिजिकल नहीं, रिटन की बात कर रहा हूँ. रिटन में फेल हुए थे, फिजिकल में नहीं. अच्छा, फेक न्यूज था वो. क्या बात कर रहे हो? बताइए, सारे सिविल सर्वेंट्स की मिट्टी पलीत कर दी. कोई बात नहीं. ऑलराइट, नेक्स्ट इज ईडीएम. ये बहुत अच्छा इंपॉर्टेंट चीज है ईडीएम. इसके क्वेश्चन भी काफी आते हैं सिविल सर्विसेज में, नहीं यूपीएससी में. आई मीन आईएफएस एंड कंबाइनिंग बोथ. सो ईडीएम, before we get into the analysis, look at some funda. The way material removal takes place, in EDM is by melting and erosion. Melting, primarily melting. So, what is the power source? Power source is a capacitor bank, huge capacitor bank. So, what exactly happens? If you see voltage versus time graph of that power source, this is the open circuit voltage. Open circuit voltage is also called no load voltage, okay? And then this is the short circuit voltage, okay? And here is the current versus time. So for a major portion of the cycle, the capacitor bank will charge. Let us say for time period T1, capacitor bank will charge. And the moment the voltage across capacitor reaches the discharge voltage, it is also called discharge voltage. Discharge voltage design is in our hand. Then what happens? Entire capacitor will discharge, and the dielectric, which was non-conducting before, turns to conducting only very small region. So during the discharge, let us say this is the discharge. T2 is the discharge time. Discharge time, and this is called charging time. So there is no current in the circuit, but only during the discharge, a small amount of current will flow in the circuit. And the same cycle keeps on repeating. And the same cycle keeps on repeating like this. ECM is high current, low voltage process. And EDM is opposite, high voltage, low current process. Exactly opposite. So T2 is this discharge time, and T2 is very small as compared to T1. T2 is very, very small as compared to T1. So during the T2, there will be a spark. So a spark is produced at the tool, transported to the dielectric, and bombard the work, and a portion of work will melt out. So when the spark is being transported through the kerosene, kerosene is the dielectric medium, a portion of kerosene will also burn. And this burning of kerosene leaves carbon residue. And this carbon residue helps in, it acts like a solid lubricant, helps in chipping the material, and within the crater, you will get a very beautiful finish. You will get a very beautiful finish because of solid lubricant that is coming out of the dielectric. Now, this material will be accumulated in the tool workpiece gap. It will affect the machining. So what exactly happened? There is a servo mechanism connected to the tool. Servo mechanism senses the voltage between the tool and the work. And when the voltage decreases below a certain value, servo mechanism withdraws the tool. And the flushing mechanism will remove all the debris from the machining area. Then again, it places back that tool back to its position. So if you see EDM, na, tool keeps on moving upward, downward, because of the servo mechanism. Okay, na? Diagram note please quickly. I'm getting into one derivation. Sometimes they ask you UPSC basically, draw this diagram, draw that diagram, okay na? So, discharge voltage is VD, open circuit voltage is, let us say, VO, okay? So, this discharge voltage is nothing but open circuit voltage 1 minus e raised to power minus t by RC. It's the formula of RC circuit. Discharge voltage is, it's not covered, na? Covered. Covered, shall I leave everything? Derivation? Is covered or not covered, tell me? Huh? Not covered, okay, let us go then. So, huh? Covered, na? Acha, theek hai. Then, I say sometimes we forget because so many things we are reading, journal studies we are reading, so we sometimes forget. But okay, VD by V naught is 1 minus e raised to power minus t by RC. This appeared in UPSC, I think, for 25 marks sometime back. Just check the papers, okay? Na? This question came, this whatever derivation we are doing. So then, shuffle little bit. E raised to power minus t by RC is equals to 1 minus VD by V naught, or V naught minus Vd divided by V naught. Take log. Take log. So minus T by RC is nothing but ln V naught minus Vd divided by V naught. Okay. So when the negative sign goes this side, na, this will be reversed. That's what happens, na? So T is equals to RC ln V naught minus Vd. So frequency of a spark, frequency of arc F is nothing but 1 by T. Okay? भोपाली, सूरमा भोपाली हैं आप, है? शोले देखिए, हमारा नाम भी सूरमा भोपाली ऐसे ही नहीं है, सूरमा. Everybody's okay? So now, because it's an RC circuit, the concept remains same. For T1, it's a charging time. It is also called idle time. It is also called idle time. Because during this time, there is no spark. But T2 is very small as compared to T1. So we can neglect T1. So energy released per spark. Energy, you already proved this, eh? You were doing something, na? You didn't. कैसे निकाला? ये प्रूव नहीं किया आपने क्या? आपने बहुत गोट रखा है, चिल बता रहा हूं. E is equals to half CVD square. If you go by this graph, it comes like the half CVD square, and the average power transferred is nothing but E divided by T. So for all calculation purpose, we can say total time is nothing but T1 plus T2, because T2 is very small than T1, so T is approximately equal to T1 for all the calculations. So now, power is nothing but C divided by 2T, and Vd is here, V naught square, 1 minus E raised to power minus T by RC square. Okay? Now, to make it simple, there are only two variables here, T and P. So do one thing, T by RC, na? So R multiply in the numerator and denominator. And let us say T by RC is another variable, let us say N. N. So average power is V naught square divided by 2NR, 1 minus E raised to power N square. And N is the only variable here. So what should be the condition for maximum average power transfer? dP divided by dN, put is equals to 0, calculate N. 25 marks in UPSC here. Temperature नहीं, time. Voltage है. देखो ऐसा होता है. ओपन सर्किट वोल्टेज इज कॉल्ड नो लोड वोल्टेज. उससे ज्यादा वोल्टेज हो ही नहीं सकती कुछ. पर हमारी जो ऑपरेटिंग वोल्टेज होती है हमेशा से कम होती है, और कितनी होगी हमें डिसाइड करना है. तो हमें पता है प्रूफ में क्या मालूम पड़ेगा हमें, कि जो डिस्चार्ज वोल्टेज मैक्सिमम एनर्जी को ट्रांसफर होगी जब वो 72% ऑफ ओपन सर्किट वोल्टेज है. प्रूफ कर रहा हूं वैसे मैं. तो हमारे हाथ में होती बीडी कितना रखना चाहें हम, तो मैक्सिमम एनर्जी ट्रांसफर के लिए में 72% होना चाहिए. वो प्रूफ कर रहा हूं मैं. हाँ, see, T2 is very small as compared to T1. So technically speaking, total time should come. But all practical purposes, I am taking T1 only, because T2 is very, very small. Okay? No? आ गया. N की वैल्यू क्या है? करो इसे, देखिए n की वैल्यू कैसे निकलेगी, आफ्टर डिफरेंशिएशन पुट द इक्वेशन इन द कैलकुलेटर, कैलकुलेटर विल गिव यू आंसर, ओके ना। Put into calculator. Calculator will give you answer. Coming in 2 minutes. After differentiation, whatever equation comes, put it in calculator. So calculator, you know what calculator will say? N is 1.26. Check. There is a way to do it. Otherwise, apply Newton-Raphson method if you have time. If you have time, apply Newton-Raphson. आ गया, आना चाहिए, 100% आएगा. और क्या टॉपिक था इसके बाद, क्या टॉपिक था लिखे थे मैं यहाँ पे, मैंने यही था बस ना. अच्छा वो कंपैरेटर, सॉरी, हाँ कंपैरेटर है गया. कंपैरेटर 2016 में क्वेश्चन है. हाँ ओ पावर सोर्स, बताइए भूल गए आप तो. कंपैरेटर पहले उठा लेते हैं, ठीक है ना. क्या हो गया, तेलुगु में बोलते हैं इसे मचपोइंदी हो गया. क्या और नहीं निकल रहा क्या. हाँ ठीक है. So this n value you will get 1.26. Put it here. You will get Vd is nothing but 0.72 V naught, and that was the answer. Prove that for maximum energy transfer in EDM, discharge voltage is 72% of the open circuit voltage. That was the question in civil services. ये GTAW का बहुत क्वेश्चन आ रहा है. देखा आपने यूपीएससी आईएएस और आईएफएस में GTAW GMW रिसेंटली 2-3 साल में 2 बार क्वेश्चन आ गया है. पेपर दिखाना जरा, बताता हूँ आपको क्वेश्चन का स्टाइल क्या होता है इसका। बहुत अच्छा क्वेश्चन है, क्योंकि मैंने स्क्रीन करते टाइम पे देखा मेरे को ये चीज है। किसको सॉल्व करना होता है? देखो ऐसे क्वेश्चन बहुत आ रहे हैं एक्चुअली इसमें। Two aluminum plates are welded using tungsten inert arc welding with the help of a welding current of Halana, Decana and all that. Okay ना, ये तो बहुत इजी है चीज है। GTAW, GMAW बहुत आ रहा है। ये 2017 की प्रॉब्लम थी। एनीवे शायद IFS में भी होगा कुछ, GTAW, GMAW का क्लास में 2015। हाँ हाँ क्या कह रहे हो? हाँ देखो जरा, हाउ द प्लाज्मा आर्क वेल्डिंग डिफरेंट फ्रॉम टंगस्टन इनर्ट गैस वेल्डिंग, ये 2015 का क्वेश्चन है, 6th B। Why is plasma arc welding associated with the high temperatures? With the help of neat sketches, explain the transferred and non-transferred plasma arc welding। ये ना बहुत इंपॉर्टेंट चीज है एक्चुअली। इसमें थोड़ा सा आपको आइडिया देता हूं मैं। अरे रुको 15 मार्क का शायद, रुको 15 था मैंने ना, 17 में जो क्वेश्चन निर्मल का आया है आपको 17 में, बंद कर दिया मैंने यार, हद हो गई। 15 नंबर का तो न्यूमेरिकल है, 17 में 15 मार्क्स न्यूमेरिकल, एंड दिस 2015 दिस थ्योरी and it's 20 marks. Oh, and they briefly explain different types of jig, what you understand by intermediate jig concept। ये आपको 10 नंबर का लिखना, जो आपको पढ़ाया मैंने आपको पूरा। Of course, I have given you only the box type jig design. Anyway, अब इसे देखो जरा, लो। Everybody is okay? Now see, I will speak little bit about GTAW, GMAW and then get into the transformer calculation. That is our topic ना। उसके बाद कंपैरेटर में घुसेंगे, ठीक है ना? Because IFS 2016 question is 15 marks question, draw the sketches of sigma comparator। ठीक है, एक दो साल बाद IAS में रिपीट, मैंने देखा था कुछ क्वेश्चंस IFS में पहले आए, then it was repeated in IAS। तो उसे देखेंगे जरा, ठीक है? Okay, so shall we hear peacefully first? इसमें डिक्टेट नहीं करूंगा because already the theory is being covered। There are different types of welding processes, and the oldest one is shielded metal arc welding, SMAW। पूरी हिस्ट्री बताता हूं आपको इसकी, थोड़ा सा जिससे आपको लिखने में थोड़ा एंथुसियाज्म आएगा। रुको, but see, next 3 lectures will be only for material science, okay na, because वो बहुत important चीज है, ठीक है ना। Today I am covering the remaining thing, next 3 lectures will be for material science, but you can ask anything, okay na। देखो फंडे देखो थोड़े से। Shielded metal arc welding, it is also called roadside welding, where there is a work, electrode holder, and there is a power source। So you have seen a cut like this, huh? Shielded metal arc welding, it is also called manual arc welding process। So now voltage and current supplied by the power source, voltage and current supplied by the power source, and let us say L is the arc length। See, any theoretical question, say I am speaking around 15 minutes, any theoretical question appears in welding, if you refer, it will be a very beautiful answer. Okay, na? Please look at what I am saying. Okay, na? Pehle suno jara. L is arc length, and the voltage across arc will be, let us say, A plus BL. It is linearly proportional to the arc length. Larger is the arc length, more will be the voltage across it. And Ohm's law means power. There is a particular power only you can draw from the transformer. So P is equals to VI. So when the voltage increases, current will decrease. Huh? Because there is a particular power you can draw from a transformer. So in manual arc welding or shielded metal arc welding, no matter how hard you try, you cannot maintain the constant arc length. You cannot maintain the constant arc length. So arc voltage will vary. And when the arc voltage varies, current will change. The molten pool temperature, it's called bead, okay na? Molten pool temperature is proportional to I square. The pool, after melting, material is coming in the pool. The pool temperature is proportional to I square. All the properties of the weld bead depends upon the current setting. So in the sheet metal arc welding, because the pool temperature is less, it will create some problem. It will create some problem. For example, flux is coated over it. And what is the function of flux? It's 3. The function of flux is 3. The most important function of the flux is it gives alloys to the bead. Gives alloys to the bead. And alloys are stronger than the pure metal. So bead becomes even more stronger than the parent metal. Because of that reason, because there will be alloys. Second function of this flux is, suppose this is the bead. This flux after melting appears in the form of a coating called slag. So over the bead material there will be slag coating. It will not allow the material, bead material, to cool rapidly. It supports the heat treatment of the bead. That is the second function of this flux. And third function of the flux is it prevents the atmospheric gases to react with the bead metal. But there is a tertiary function. Number one, it gives the alloy, making the bead strong, because alloys are stronger than the pure metal. Tomorrow we will discuss that concept in material science. Number two, it supports the heat treatment. And number three, it protects the bead from the attack of atmospheric gases. Okay? Bagunnara? Kannada also bagunnara na? No. Huh? Telugu Kannada is same. How you know Telugu? You know Telugu? Okay. Shielded metal arc welding, because I cannot control the arc voltage, there will be variation in the arc current. Because there will be variation in the arc current, temperature of pool will also change. So it leads to defects. You know what kind of defects it will lead? When the electrode is getting melted, a mixture of metal and flux will come to the groove. The flux is having lower density. So due to the lower density, flux will try to come up over the surface and it appears in the form of slag. So when the temperature of the molten pool is low, the bead will solidify early and a portion of slag will be trapped inside the bead. And this defect is called slag inclusion. Slag inclusion will appear. Slag inclusion will appear only when. Slag inclusion will appear only when temperature of the molten pool is low. और जबरदस्त फोन लेके चल रहे हो क्या? पुराना बाबा आदम जमाने का फोन है. डिपार्टमेंट दिया क्या? डिपार्टमेंट के सारे फोन ऐसे ही होते हैं जो ना जैसा इट कैन नॉट बी स्मार्टफोन. चाहे कितना ही बड़ा ऑफिसर हो. Because I work in NFC basically for some time, so all these people do phones are not allowed. Only the GM level people are phone allowed. And वो phone होगा जो आपका जैसा टिक टिक टिक. Phones are, it's a highly confidential lab in Hyderabad. Nuclear field complex. Most of the bomb material is manufactured there. Okay. Huh? No? So anyway, slag inclusion is due to low molten pool temperature. So all the defects in the welding is due to improper setting of current because it leads to change in the current. Everybody is okay? So shielded metal arc welding, the problem is that length of electrode is limited. There may be problems in the weld bead. So because we cannot control the current, transformer has to do. So that is the reason in case of, it's a manual arc welding. Manual arc welding. So on all the manual arc weldings, we use constant current transformer. Constant current transformer or called drooper. Constant current transformers are also called droopers. And the drooper characteristic is like this. Voltage versus current. See, the problem is, changing the arc length is changing the voltage. And changing the voltage, if it changes the current, there is a problem. So in the drooper what happens? In the drooper what happens? Large change in the voltage have insignificant change in the current. Large change in the voltage have insignificant change in the current is a characteristic of drooper. So drooper we use in the manual arc welding. Okay? There is something called manual arc welding, semi-automatic, and automatic arc welding. Do you have numericals on welding so that we can practice something? आपके न्यूमेरिकल है इसमें कहीं वर्कशीट में है ना? ठीक है, we will take up. Okay ना? कहाँ पे है? वर्कबुक में. हाँ. अच्छा ठीक है, वर्कबुक में है, उससे करेंगे. ठीक है ना? Okay. So manual, semi-automatic, automatic. Who knows? What is the difference between these three? Who knows? Huh? No. I will tell you. There are two movements of electrode in welding. There are two movements of electrode in welding. To maintain arc, between electrode and the work, there should be some gap. Otherwise, even the arc, you will not get it. So, इसे सुनो ठीक से, otherwise समझ नहीं पाओगे इसे. समझ लो इसे, समझ नहीं पाओगे otherwise से. There are two movements of electrode. The rate at which the electrode is being consumed, with the same rate, electrode has to be fed towards the work. Otherwise, there will be change in the arc length, and change in the arc length changes the arc voltage, it changes the arc current, it follows the chain reaction, and we will get very poor weld. First movement is feeding of electrode towards the molten pool. And number two, movement of electrode along the longitudinal direction of the weld. Correct, na? When both these movements are controlled by a person, it is called manual arc welding. And in manual arc welding, I will use droopers. And when the first movement, what is the first movement? Feeding of electrode towards the molten pool is controlled by machine. It is called semi-automatic. And in semi-automatic, we use constant voltage transformer. And the constant voltage transformer, VI, will always be straight line. But it depends upon type of transformer again. It will be straight line. And constant current, it will be drooper. And the relationship between voltage and current will be, अरे आगे बैठ जाओ, इसी ठंड लग रही है क्या? So voltage is nothing but open circuit voltage minus open circuit voltage over short circuit current into I. Open circuit voltage is a no load voltage. And short circuit current is where the voltage becomes zero. That's what it is, na? Good. So, when the, see, I do one thing, you observe here, okay, na? Then I will give you 2 minutes free time to copy all these things, whatever is there in the memory, because all of you are champions, I think we can manage. Otherwise, I have to dictate basically in regular batches. Okay. When both movement, first movement, feeding, second movement, longitudinal movement, both are controlled by a person, it is called manual. When the first movement is controlled by machine, it is called semi-automatic. And when both the movements are controlled by machine, it is called automatic. For semi-automatic, automatic, I will use constant voltage transformer. For manual, I will use this. Right. In your own words, quickly. In your own words, quickly. देखा ना वर्कबुक में कौन कौन सी प्रॉब्लम है इसमें? क्या मेरे पास वर्कबुक नहीं है एक्चुअली इसमें? किसी के पास है? अच्छा, इस बुक में है। चलिए कोई मैंने निकाल दो, उसे देख लेते हैं ऐसे कि मेरे पास कुछ भी नहीं है मटेरियल अभी। ये जबरदस्त पढ़ा है आपने, रियली बता रहा हूँ। और उसमें से नहीं मालूम नहीं आपको ना? अच्छा है नहीं, ये तो इजी है, कुछ नहीं है उसमें। ठीक है, हाँ मैं उससे कुछ क्वेश्चन बता दूंगा आपको, ठीक है ना? एवरीबडी डिड? हाँ, इसमें नहीं, आपकी बुक में दे रखा है, जो बुक में लिया आपको ना, उस बुक में है कुछ क्वेश्चंस। यूपीएससी में ऐसे क्वेश्चन आते हैं इसके, ठीक है ना? रिसेंटली 2017 में है क्वेश्चन, वो उसी क्वेश्चन को कर लेते हैं 2017 वाले को, ठीक है ना, जो आया है। ओके, एवरीबॉडी इज ओके? अरे एवरीबॉडी इज ओके? हाँ, वो बताएंगे आपको, आर्क बताएंगे, बिकॉज दैट इज GTAW GMW, दैट कंसेप्ट कम्स, ओके ना? GTAW GMW। ओके, shall I move forward? अभी आपको थ्योरी पढ़ा रहा हूं मैं, अभी न्यूमेरिकल गया नहीं, ठीक है ना? ओके, now shielded metal arc welding is a manual arc welding process. Semi-automatic version is submerged arc welding. Submerged arc welding, SAW process. SAW process. So, you know, in here, First movement of electrode will be controlled by the machine. An arc is submerged in the pool of flux. So electrode is in the form of a spool of wire. Here is a work, and there is a container where there is a granular flux. Granular flux. And the flux is thrown into the welding area. Power source. It will be constant voltage power source. An arc is submerged in the pool of flux. And the first movement is controlled by the machine. SMW, SAW. Is that okay? Now see, 5 minutes everybody will hear me. Because UPSC, this question GTAW, GMAW is coming frequently. So I want to touch that topic. Okay, so I will not be able to dictate everything. But concept everybody should hear. There are 4 materials. And each material is difficult to weld due to its own reason. Copper is very difficult to weld. Everybody knows that because copper is having very high conductivity. The moment you use a heat source, most of the heat will be dissipated. So lesser energy is available for melting. So copper alloys are very difficult to weld. Number 2, cast irons are very difficult to weld. You know why? सूरमा बताएंगे आप? सूरमा उससे क्या होगा? उससे क्या होगा? You know, whenever you use a heat source, शर्मा जी धीरे धीरे मुस्कुरा रहे हैं. देखो उससे होता क्या है शर्मा जी बताए. हाई कार्बन कंटेंट से क्या होगा? Whenever we are using a heat source, because excess amount of carbon, of course, the materials and some inner details I will give, a portion of carbon is start coming out. And the regions where the carbon is coming out, there will be cracks. Okay? So, very difficult. Only way we can weld cast iron is by using carbonizing flame. Otherwise, it is impossible. Okay? Aluminium is very difficult to weld. I have discussed with copper. Cast iron, aluminium, एक और material है कोई? Anybody knows? No, aluminium, yeah, magnesium, correct. नहीं, aluminium, magnesium concept same है. एक और कोई concept होता है actually just because welding I did not thought of basically to speak, huh? No, titanium, you know, it's a different reason actually. No, titanium we are not talking about here, huh? Yeah, you are, no, stainless steel, sorry. Not mild steels are very easy. Stainless steel, okay. पहले stainless steel को देखते हैं. Now, stainless steel contains 18% chromium and 8% nickel. And this chromium is present at the grain boundary. Tomorrow I will explain to you how exactly corrosion resistance is being provided. Tomorrow is that day. How the corrosion resistance is being provided by the chromium. Tomorrow we will discuss. So what exactly happens? There is a bead, there is a heat affected zone, and there is a parent metal. In heat affected zone, temperature of material is already above recrystallization temperature. So what exactly happens? If you are welding stainless steel, chromium present at the grain boundaries reacts with the carbon already present in the material and produces chromium carbide. And chromium carbide just like a powder. So on the surface of heat affected zone, you will find chromium carbide deposits, just like powder, white powder. So after welding, it appears that welding is okay. But welding is not okay. In the heat affected zone, there is no chromium at the grain boundary. So, this portion after some time start corroding. And this phenomena is called weld decay. Correct or no? So, stainless steels are very difficult to weld. So, can you tell me how can I weld stainless steel? No. It's impossible. See, how to weld stainless steel then? Huh? No, focus on concept. Huh? Huh? Are soldering, what is the strength? See, so focus on the concept. See, there is one very big concept in welding. More concentrated energy source it is, we can go for higher welding speeds. And if the welding speed is higher, energy source will have less time to interact with the surroundings. So heat affected zone will be lesser and lesser. And this is possible in plasma arc welding and electron beam welding. So plasma arc welding, electron beam welding I will use for stainless steel because heat affected zone is almost nil. Once again, more concentrated source of energy it is, more will be the welding speed, and as the heat source will have less time to interact with the surrounding, so lesser will be the heat affected zone. Easy ga unnadi or difficult ga unda? Easy? Our Tamil friend in the back, you are okay? Appearing in mains, na? Next year you will appear. Next year definitely you have to appear. भोपाली, आप लोग समझो ना, नेक्स्ट ईयर क्रैक करना है सब कुछ. Everybody is okay? So now aluminum is also very difficult to weld. Aluminum is also very difficult to weld. You know why? Yeah, very good. I will tell you. Welding, be little careful because your paper setter is a welder. One of the paper setter is a welder, welding person from IIT Delhi. Three people team, he's one of them. Okay, na? Other two, I don't know because he's my professor. I am from IIT Delhi. So I spent almost 7 years in IIT Delhi, 2 years MTech, then 2 years IES job. Then PhD again from IIT Delhi. So I know all the stuff of mechanical. And I have good relations with everybody and all the teachers. So he himself told me. I will not tell you the name, otherwise there will be issue. So welding question you can expect this year. Okay, no? So be careful. Dekho suno. Ceramics are oxides and carbides of any metal. There is a way we define ceramic, na? Ceramics are oxides and carbides of metal. Not always. Okay, na? Some of the oxides and carbides of metal are called ceramic. Not all the oxides are ceramics. This aluminum oxide is a ceramic. And its melting point is close to 5,000-6,000 degrees centigrade. So, when aluminum is exposed to atmosphere, instantly it forms aluminum oxide. and it's a ceramic. So when you want to penetrate the thickness of aluminum oxide, you have to use a large energy source. You have to use a large energy source. But if you use intense energy source, aluminum beneath is having very low melting point. The metal will flow like a water on the table. It is very difficult to weld. So to weld aluminum, somehow this oxide layer should break. Without breaking the oxide layer, it is impossible to weld aluminum. And GTAW was primarily invented to weld aluminum. That is the history of GTAW. Gas tungsten arc welding. GTAW is gas tungsten arc welding. Gas tungsten arc welding. Just 2 minutes on the board. GTAW is exactly similar to SMAW. Only difference is that it's a non-consumable electrode. It's exactly same. Non-consumable electrode, work, power source, and there are channel to throw argon or helium gases into the welding area. And to deposit material, we are using a separate filler rod. It's exactly same. Only difference is here it's a non-consumable electrode. Especially in welding, na? Some of the Indian authors has made a mess out of it. Especially the P.N. Rao and all these people. Okay, na? Correct welding books are only 3. Professor A.C. Davis. Little is a very popular book in IIT circle. I think you must have studied Little. Welding padha nahi padha? Little. You know, there is a book called Little. Which book you followed? Ghosh and Malik. Little is a very beautiful book. A.C. Davis and my teacher also has written R.S. Parmar. Volume 1. Volume 1 is your syllabus basically for UPSC. Volume 2 is basically mostly design. So otherwise P.N. made a blunder basically, or most of the Indian author books, by the way. So GTAW was invented primarily to weld aluminum. And in that, workpiece was given negative polarity and electrode was given positive polarity. Because as the electrons are coming out of the work, it will peel off the ceramic layer and the fresh aluminum will come in contact with the arc. And this phenomena is called cathodic cleaning. This phenomena is called cathodic cleaning. And without cathodic cleaning, it is impossible to weld aluminum. In AC welding, cathodic cleaning will be only partial. Weld will have defect. So ideally, you know how we can weld aluminum? Give the work negative polarity and the electrode positive polarity. Only then we can weld aluminum. But you know what is the problem? What is the problem? In DC welding, wherever electrons are bombarding, 2/3 heat will develop. And from wherever electrons are coming out, 1/3 heat will develop. So when electrons are bombarding the tungsten, a portion of tungsten will erode and it will mix with the bead material and making it brittle. So current has to be adjusted. Because for aluminum we need a cathodic cleaning. Without that we cannot weld. And a DC welding, wherever electrons are bombarding, we will get 2/3 heat. And from wherever electrons are bombarding, coming out, we will get 1/3 heat. So now GTAW, what is the GMAW? Gas metal arc welding. In place of the consumable electrode, in place of non-consumable electrode, there will be consumable electrode in the form of wire. So GMAW is exactly similar to submerged arc welding, and GTAW is exactly similar to the SMAW process. SAW and GMAW are semi-automatic. GTAW and SMAW are manual. GMAW is the semi-automatic version of GTAW. So when we want larger metal deposition rate, I will give electrode positive polarity. 2/3 heat will develop, so more metal will melt out. But when the thickness of work is large, I need deep penetration, I will give work a positive polarity. So polarity we choose depends upon what we want. Polarity we choose depends upon what we want. Are you understanding what I am saying? Now, DC welding is having all the good qualities, but there is one bad quality. DC welding is our arc stability is better. We can manage the metal deposition rate. We can manage the penetration. There is so many good qualities we have DC welding, but it has got one bad quality. Bad quality, you know what is bad quality? Arc blow. Because you said, nah, that wasn't the card. Suppose this is the work. And here is the electrode. So, because of fixed polarity, because in AC welding polarity keeps on changing. Because of fixed polarity, magnetic lines will form between the work and the electrode. It happens when the polarity doesn't change. So magnetic lines will form. And it's an electrical engineering principle. Most of the magnetic lines will be concentrated in the work, because in the metal, not in the air. Most of these magnetic lines will be concentrated in metal. When you are performing welding operation at the center of the work, magnetic lines are equally distributed on both the sides. So arc will be straight. But when you are performing the welding operation near the edge, since most of the magnetic lines are in the work, arc will deflect towards the work. Arc will deflect towards the work. And this leads to severe spatter. Spatter means kya hota hai? The metal that is not on the bead on the side. It leads to severe spatter. And this phenomena is called arc blow. Arc blow phenomena primarily appears in DC welding. In civil services, there was a question on arc blow, na? See, civil services from welding, though, what kind of question appeared in last 10 years if you see? What is arc blow? And in the metal transfer, they ask about the dip transfer and all these things. Are you reading questions or no? Those are appearing in the mains. Welding, these are the questions. Welding and the metal transfer, what are the forces? Here are some of the questions in UPSC, IFS and IES both, if you combine. So, tell me how to avoid this arc blow. How to avoid this arc blow? Shielding of what? You are correct. That is the way. Very good, very good. Place another metal here and here. Very good. कहाँ से इंजीनियर किया है? बीटेक कहाँ से कर लिया? KIIT. अच्छा, KIIT. सिविल सर्विसेज दे रहे ना मीन्स? अरे वेरी गुड, वेरी गुड. ऊपर वाले चाहा तो सिलेक्शन भी होगा. इधर ठीक से करो सब कुछ, ठीक है ना? Entire production and all that you can ask me even anything, whatever problem you have. Okay. Put a metal here at the entry and exit. So magnetic lines will continue in this metal. So arc will remain straight. These are called tab ins and tab outs. These are called tab in and tab out. Okay? Easy? सब कुछ easy है. Nothing is difficult. Everything is easy. I have to finish comparator also before 12 o'clock. Okay. Let us see. Look at the board. Look at the board. This is little technical. Understood what is the manual semi-automatic welding? There are many welding processes. मतलब सामने कराया होगा कुछ ना welding processes वगैरह के बारे में. मैं just filling the blank कर रहा हूँ आज, ठीक है ना? जो कुछ बचा हुआ है, ठीक है ना? बाकी कुछ नहीं कर रहा हूँ, ठीक है? Fill in the blanks. GTAW, S7W, manual. So manual, and there is a semi-automatic. Semi-automatic, like GMAW, SAW. Plasma arc welding is also, by the way, it's a manual. जो 20 नंबर का क्वेश्चन है 2016 में, सब लिखना है, तामझाम पूरा लिखना है, सब फंडे लिखने हैं उसमें. आईएएस में 20 मार्क्स का क्वेश्चन है, पढ़ाया था मैंने आपको. जो प्लाज्मा के बारे में भी लिखा हुआ उन्होंने. प्लाज्मा इज ऑटोमेटिक, सो मैनुअल. But the plasma temperature for welding is restricted to only 20,000 degrees centigrade. So here be a little careful for hitting numericals. In manual arc welding, it will be drooper, and here it will be the straight line. Generally in the question it will be given that what kind of transformer we are using. In the question it will be given what kind of transformer you are using. But suppose it is not clearly mentioned in the problem that what type of transformer you are using. See the equation. If the equation is that of a parabola or ellipse, it means it's a drooper. If the equation of transformer is either parabola or ellipse, it means we are operating a drooper. And when the equation is a straight line, it means it's a semi-automatic constant voltage transformer. It's a constant current transformer. It is called constant voltage transformer. ठीक है ना? There are two different things. And for arc stability, if you are using a drooper, when the arc will be stable, current across arc and current across transformer should be same, only then the arc will be stable. But when we are using constant voltage transformer, arc stability condition is voltage across arc and voltage across transformer should be same. Then the desired thing will come. You understand ना? ये क्वेश्चन एक्चुअली कहाँ होगा? See, I will not go detail basically. See, the question can appear like this. See, I'm reading the question. The arc voltage characteristic is given by the expression V is equals to 24 plus 4L. The volt ampere characteristic of power source can be approximated by a straight line. Means with open circuit voltage 80 volt and short circuit current is 600 ampere, determine the optimum arc length for maximum power. For that, you know what you have to do? This. When you do this, answer will come out automatically. Okay na? Okay na? Another question. Volt ampere characteristic of a power source is given by I square is equals to minus 600 V minus 60. It means it's a constant current transformer. If the arc characteristic is I is equals to 20 V minus 16, determine the power of a stable arc. Means for arc stability, equate the current. Whatever condition comes out, V power is equals to V into I, that is the answer. Are everybody's okay? If it's a drooper, for arc stability, equate the current across arc and power source. If it is a constant voltage power source, when we use in semi-automatic welding, equate the voltage across arc and the power source. One question I want you to solve here. Okay ना? ये सब कुछ हवा में नहीं चला जाए. एक क्वेश्चन है. Write down this question. Okay ना? एग्जाम का एक क्वेश्चन है, पता नहीं कहाँ का है, या गेट का है, आईएएस में से किसी एक का है. Write one question. Arc length voltage are represented by arc length and voltage are represented by V is equals to 20 plus 4L. V is equals to 20 plus 4L. ये arc voltage है, ठीक है ना? Represented by C. Full stop. If the arc length varies between 4 to 6 mm, if the arc current varies between 450 ampere to 550 ampere, in the power source, I can vary the current between 450 ampere to 550 ampere. What is open circuit voltage and short circuit current? What is open circuit voltage and short circuit current? See, look at the board. Look at the board. Oh, एक चीज और कराएंगे इसमें वेल्डिंग में बिफोर मूव टू कंपैरेटर. वन मोर थिंग, ओके ना? इसके बाद एक चीज जो कराएंगे जिसका न्यूमेरिकल है ना, उसमें 2017 जो न्यूमेरिकल है ना उसके बेस पे थोड़ा सा बताएंगे, ठीक है ना। सी लुक एट द बोर्ड, लार्जर द, सब देखो जरा, बहुत इजी है। लार्जर द आर्क लेंथ, more will be the arc voltage, power source is same, larger the voltage, smaller will be the current. So smaller the arc length, शर्मा जी इधर देखो गलती हो जाती है इसमें, smaller is the arc length, smaller will be the voltage, so corresponding to 4 550 ampere and corresponding to 6 450 ampere. Do it quickly. Understand ना? Quickly do it. 2 मिनट में आंसर निकालो इसका. Hundred % correct. $80 and 1,000. $80 and 1,000. $80,000 everybody getting? Huh? Getting or no? 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 देखो, C is very easy. So corresponding to arc length of 4 mm, what is the voltage? 36 volt. Corresponding to 6 mm, 44 volt. Okay, now see. Because it's a constant voltage transformer, V is equals to open circuit voltage minus open circuit voltage over short circuit current into I. लगाओ. Corresponding to 36 volt, it's a 550 ampere and this is 450 ampere. So देखो, 36 is equals to OCV minus OCV over SCC into 550, first equation. 44 is nothing but OCV minus OCV over SCC into 450. Two equations, two unknown. Means there next bar? Okay, no problem, no problem. Next year. कहाँ से फोन आ गया? Welding ठीक से करना, because I hope that he will put one question. Okay. पेपर 2 हो गया आपका, पूरा खत्म हो गया पेपर 2. कंप्रेसिबल फ्लो. Manoj Gaur will come. He will come. Good teacher. Compressible flow. That is very, very important. Because one question from compressible flow 100% will come. Okay, so take it seriously. And flue gas analysis. So these questions are coming every year almost. Sometime there is a googly. Flue gas analysis and compressible flow has to be done. Fluid mechanics, who taught? Fluid machinery, हाँ. Gas turbine है. So that portion not covered है. Compressible flow, who taught? Saurabh Pandey. अच्छा. Okay. Is that correct? Now, last thing in the welding. सब लोग इधर देखो. It's because 2017 based on this concept only question is there. Okay, na? Look at the board. In resistance welding, there are two sheets or plates. देखो little bit, you have to see that clearly. So, two sheets are held together in the between a pair of electrodes. Then there is a power source, and the power source is a step down transformer. पहले सुन लो, it's so easy. सुनो पहले, because funda comes first. It's a step down transformer, and in the secondary winding of which there is only a single turn. So currents are quite high, almost 10,000 to 20,000 ampere. You know, we apply pressure on these electrodes to have indentation. Why we want to have indentation? So that there is no air gap here. Because if there is an air gap, it will increase the resistance. Between the path of current, in the path of current, 5 resistances are coming into picture. Resistance offered by the electrode and the sheet, this thickness, the interface between the sheet, R4 and R5. 5 resistances are coming in the path. And we want that R3 should be maximum because there will be some air gap between the two sheets. And due to that, resistance will be high. If we don't apply pressure, there will be air gap here also. Because heat generated is nothing but I square RT. T is the time period during which you are supplying the current. So, heat will develop wherever the resistance is high. If you don't apply pressure, heat will develop here and an electrode will be welded to the sheet. So now, there is an air gap between the two sheets, so maximum resistance on the interface. So, when the current flows, material in both the sheet melts out. And after solidification, there is a welding. So the efficiency of welding is nothing but I square RT is the heat required in welding divided by the total energy supplied. Total energy supplied, or you can say it can be given in a different form. Total energy supplied. Total energy supplied. Now, in the welding, in arc welding also there are many efficiencies. In the arc welding, इसे थोड़ा ठीक से देखो. Arc welding also there are many efficiency. There is something called melting efficiency. Melting efficiency. Energy falling, or just a minute, I will tell you, because sometime between the two I get a little confused. Exact things should be communicated. That's the reason I'm looking at the notes a little bit. Okay, melting efficiency, and that is called heat transfer efficiency. Heat transfer efficiency. That's the difference. See. Total energy supplied is V into I. Is the total energy supplied? how much energy is falling on the work? Energy falling on work divided by the energy supplied is called heat transfer efficiency, because a portion of energy will be lost in radiation. So, heat transfer efficiency. Total energy supplied VI. How much energy is falling on the work? But out of the total energy falling on the work, how much energy is utilized in melting or in the formation of bead? Because a portion of energy will go to the heat affected zone. Called melting efficiency. So these efficiency you should know before operating any question on welding, and then rest of the question will be very easy. निकालो उस क्वेश्चन को, निकालना जरा. The question I don't have. 2017 IAS. There question. Oh, time is flying like anything. IAS 2017, question number 6B. It's a 15 marks question. फोन में क्या दिख रही हो? पेपर ना? अच्छा, पेपर देख सकते हो. मेरे पास एक कुंजी है. Two aluminum plates are welded using tungsten inert gas welding process with the help of welding current of 150 ampere and the voltage of 12 volt. Arc travel speed is, it's also called welding speed, 2 millimeter per second. Considering the heat transfer efficiency 90%, heat required for melting aluminum is 15 joules per millimeter cube. Calculate the melting efficiency of the process. The cross-sectional area of the weld joint is 20 millimeter square. Cross-section area means, देखो, suppose this is the bead. So this is the cross-section area question is talking about. So see. Metal deposition rate will be nothing but cross-section area into welding speed. So 20 millimeter square multiplied by 2 comes out to be 40 millimeter cube per second is the welding speed. Multiplied by this, you will get total energy input. Total energy input will be nothing but 15 into 40 watts, because joule per second is watts. Karo. This is the basically total energy consumed in melting. Tell me quickly. Doesn't take much time now. लीजिए अपना पेपर लीजिए अपना. Good, you have this compilation, है? हाँ? Quite possible. See, देखो, अब तो बहुत easy है, कुछ नहीं करना है इसमें. Let us say, what is the overall efficiency now? 0.9 into melting efficiency into V into I should be equal to, understood na? Should be equal to 15 into 40. Tell me, what is the melting efficiency? 37%? Okay. Check. Others should also check the answer. 37%. So welding questions are very easy. बहुत बड़ा इसका चूज कर रहे हो तुम, हैं? पेन नहीं है क्या? फिर जिसे ज्यादा पेज भरे हैं कैसे हैं आप? ठीक है? Everybody getting 37%? अगर ये स्पीड से हम नॉर्मल इवन टैलेंट बैच में जाते हैं ना, लोग टेंशन में आ जाते हैं अरे सर क्या हो रहा है, बहुत फास्ट जा रहा है यहाँ पे पर यहाँ तो सवाल बनाने, थोड़े बेसिक फंडा बताने हैं, आप लोग एब्जॉर्ब भी कर सकते हो, है कि नहीं? But I know when we teach in the regular, because there will be one batch from September 1st, na? There we will teach systematically. I mean, the way we are teaching in the tail end batch, little faster than the tail end batch, because we have less time. But here it's only questions and because we have to appear in exam. October end, September end. Oh, send me the paper once the paper is over, na mechanical. Send me the link, okay, na? Because I would like to see it. Okay, before we jump to the material science comparators. Comparators. (2016) it is there in the IFS, and there are repetition from IFS to IAS. Okay, na? So be careful. Okay, na? So question was, elaborate in the design construction of a sigma comparator. That was the question on IFS 2016. Okay. Okay. Comparators are not used in the absolute inspection. They always give variation in the dimension from a certain datum. And this datum is being established by using the slip gauges. This datum we established with the help of slip gauges. IIT Kanpur, they don't teach a comparator. Why? No. Every IIT they taught. Roorkee, comparator metrology. भूल गए होंगे? ये आज हर जगह ये हो गया है ऐसे रुड़की, एक्चुअली मेरे बहुत सारे फ्रेंड रुड़की में है, रुड़की एंड खड़गपुर में हमारे बहुत सारे फ्रेंड हैं जो प्रोफेसर एसोसिएट हैं सब लोग। इंद्रवीर सिंह, इंद्रदीप सिंह, इंद्रवीर मेरा कॉलीग है, इंद्रदीप मेरे जूनियर था आईआईटी दिल्ली में, तो सब ये कॉलीग ही हमारा एक्चुअली वो भी स्लाइड मारते हैं क्या इंद्रदीप? नहीं पढ़े? हाँ इंद्रवीर, अरे नहीं पढ़े, कमाल है यार। तो स्लाइड का सिस्टम आईआईटी में ऐसा नहीं है कोई तोप चीज हो वहां पे टीचर्स वगैरह, वहां भी बहुत बड़े गड्ढे होते हैं एक्चुअली, समझ रहे हैं ना आप? आपको मालूम पड़ेगा आईआईटी को काफी लोग हैं यहाँ पे, है कि नहीं? गड्ढे वहां भी होते हैं। गड्ढे का मतलब समझते हो? जिसको कुछ नहीं आता टीचर को, ऐसे लोग आईआईटी में भी होते हैं, पर कम होते हैं। पर बाकी कॉलेज में सभी लोग गड्ढे होते हैं। मेरे 2-4 टीचर मिल जाते ठीक ठाक से। हाँ, बात बिल्कुल सही कह रहे हो। है ये जीएस का टॉपिक है रियली? तो आप okay, he's thinking, he's very fast. Immediately he's thinking how to basically okay, comparator. There are 2 types of comparator. तो जीएस का टॉपिक पढ़ेंगे। There are broadly 2 types of comparators. Of course, there are electronic, electrical that it's not in our course. First is mechanical. Second is pneumatic. Mechanical comparators are 2 types. First is sigma. Sigma. थोड़ा खुश रहा करो आप, ऐसा समझ रहे ना, मुस्कुरा के जिया करो थोड़ा सा, इससे पता 10 नंबर और ज्यादा आएंगे फिर मैकेनिकल में। खुश रहो, समझ रहे ना। सो देखो सब लोग, देखो कंस्ट्रक्शन कैसे होगा। एवरीबडी शुड लुक एट द बोर्ड, इट्स वेरी इजी। देयर इज अ मेजरिंग लिंक, there is a measuring link, and below the measuring link we are keeping our workpieces. So you know what we do? Initially develop a dimension using the slip gauges, put it under the measuring link, set 0 in the comparator, remove the slip gauge. Now keep on putting the workpieces below the measuring link, and the measuring link will give the variation from a certain datum value. Because in metrology, if you want to maintain accuracy of equipment, allow the equipment to travel shorter distances. Otherwise, you cannot maintain the accuracy in measurement. Now, between the 2 readings, नहीं ऐसे ऐसे मत बनाना, हमारा डायग्राम लेफ्ट को फ्लो करेगा। हाँ। Between the 2 readings, my comparator should come to the neutral level. Otherwise, how will I make the measurement? So there has to be a restoring device. So immediately we think of springs. But helical springs are not used anywhere in the metrological equipment, because due to development of residual stress, it takes time for the system to come back to its original position. So we don't use a helical spring, we use diaphragm springs. We use diaphragm springs diaphragm spring. Diaphragm spring is like a sheet. So sheet, go down like the sheet. If you see the plan of diaphragm spring, it's a sheet, and here's a measuring link, and in this sheet there are C slots. There are C slots. C slots. It's a design principle that wherever there are chances of development of residual stresses, provide holes. So C slots are provided to relieve the residual stresses if it develops. Okay, now this measuring link is connected to a knife edge, and this knife edge is screwed to the link. These are screws. Why we wanted to have knife edge? So that there is a single point contact. If it is an area contact, again the measurement will be affected. Knife edge is used so that there is a single point of contact. This knife edge is resting on a floating fulcrum. This is a moving end. It is a fixed end. Floating fulcrum means, see, one end is fixed, another is floating. Why we do this arrangement? that always there is a positive contact between the fulcrum and the knife edge. And moving end is connected to a fork. And on this side of the fork there is a metal ribbon. Metal ribbon. Now over the metal ribbon there is a drum. Sharma ji, this side mein. There is a drum. At the center of the drum there is a needle, and that moves over a scale. So you know what happens? See what happens? By the variation in the size of work, measuring link will move up and down. And due to that, the fork will swivel, drum will rotate, and the readings will be changed. But suppose there is a huge variation in the dimensions. And when you remove the work, measuring link may experience some jerk. Jerk should not appear anywhere in the metallurgical equipment. You know why? Again, it may develop the residual stress. So what we do? Jerk should not appear anywhere in the metallurgical equipment. So what we do? We provide a magnet. We provide a magnet just above the measuring link. But magnet doesn't come in contact with the measuring link at any point of time. So when the measuring link is moving up, attractive force will develop between the link and the magnet. And when you remove the work, slowly, measuring link will come back to its neutral position. So the purpose of this magnet is to have uniform pressure on the link. And this is called sigma comparator. Do it quickly, do 2 minutes. ठीक है भाई सब लोग, असिस्टेंट कमिश्नर ऑफ इनकम टैक्स हैं आप, हैं शर्मा जी, और रेवेन्यू सर्विस ना, जीएसटी एंड इनडायरेक्ट टैक्सेस. अच्छा. चलो इस बार आईएएस बनो, थोड़ा सा अच्छा लगा. आईएएस आईपीएस की बात अलग होती है ना. इस बार नेवर करना है. कोई दिक्कत है मेरे को फोन करो आप, ठीक है. Between 8 to 8:30 बता देना, मैं नेक्स्ट आईएएस से हूँ, ठीक है. अदरवाइज ना आई डोंट एंटरटेन स्टूडेंट्स फोन. सपोज गेट नेक्स्ट आईएएस जो, इफ यू आर टेकिंग सम हेल्प, you tell that I'm from next IAS, okay na? Then you ask anything. So between 8 to 8:30, ask anything. Any question up to this point? Because I have to leave. So tomorrow what we will do, I will do one more comparator. Then I will jump into material science. And what kind of questions appears in material science, I read it out in the beginning. So we will be discussing on those lines. Okay, some important things I will dictate it to you. But primarily you understand what I am speaking. Okay, so next 3 lectures will be on material science only. कौन सी शीट, हमने कौन सी शीट दी है यार? हाँ, कौन सी शीट है बताओ मेरे को, दिखाना जरा 1 मिनट. आंसर मैं कल ही डिस्कस करूंगा. शीट दिखाओ जरा. शीट का मेरे को शीट है नहीं, टू बी फ्रैंक विद यू. लाला कहाँ है? ओहो, नैनो टेक्नोलॉजी. मैं कल बता दूंगा आपको जैसे चल रहा है. नहीं देखो ऐसा करते हैं, सुनो बहुत अच्छी चीज बता रहा हूं आपको मैं, पकड़ो से. मैं पहले आपको ना स्क्रीन करूंगा, जो हमने सिविल सर्विसेज का क्वेश्चन थे ना, उसी लाइन पे स्क्रीन करूंगा चीजों को मैं. और मे बी 4th डे वी विल टेक अप दीज थिंग्स. So you yourself will be able to hit most of the questions. Okay ना? प्रिंट आउट तो नहीं है मेरे पास. मैं बात करता हूँ, ठीक है ना, मैं बात करता हूँ, ठीक है ना, क्योंकि जो मैं तो आईएएस के कंपाइल्ड क्वेश्चंस हैं आईएएस के, उसको डिस्कस करूंगा मैं, ठीक है. लास्ट ऑलमोस्ट 10 years आई स्क्रीन द क्वेश्चंस ऑफ मटेरियल साइंस, जो आपके बात कर रहे हैं. किसका? नहीं, देखो ये है मेरे पास, मैंने ऐसे लिख रखा है, देखिए आप शर्मा जी को दिखाते हैं, देखो मैंने ऐसे लिख रखे हैं कौन कौन से क्वेश्चन थे, ये ऐसे मैंने लिस्ट बनाई है, ठीक है ना. ये इसकी तरह पे जाऊंगा मैं, आईएएस के क्वेश्चन हैं, चलिए इसकी तरह पे आपको डिक्टेट करूंगा कुछ चीजें. और फिर फोर्थ डे हम क्या करेंगे कि अगर सपोज सॉल्यूशन अवेलेबल नहीं है तो हम इसको एक दिन ऐसे भी देख लेंगे, ठीक है ना, इसमें चलेंगे, ठीक है. थैंक यू वेरी मच. सी यू टुमारो 8 o'clock. ट्राई टू कम एट 8 o'clock sharp. ओके.